MATLAB, which will be quite useful for carrying out research. It's my pleasure to introduce Madam Shimi SL. She is Assistant Professor in Electrical Engineering Department at NITR Chandigarh. She has a long experience of 13 years in teaching. She joined this institution in 2011. Prior to this, she was working with Chitkara University, Rajpura for about 2.5 years. Her areas of specialization are power electronics and drives, digital control, ANN and fuzzy logic applications, renewable energy, soft computing techniques, MATLAB, SIM power system toolbox, optimization techniques such as generic algorithms, and practice swarm optimization. She will be interacting with you on MATLAB in these two sessions. I request her to interact with you on this very important software.
A very good morning to one and all. So today we'll have a lecture on MATLAB. Okay, so can anyone say which is the latest version of MATLAB? 14. 14 is very long back. So it is, say, 16B has come to everyone, even 17A. In every March and September they'll be releasing. So this March 17A would have come. Okay, so in every version, mainly if you see, the main difference is they add lot of demos, that is real-time problems. And after 13, the version 13, if you would have seen, it is app-based. Number of apps, like say how mobile is having the number of apps. So this, they made this MATLAB also app-based. So all the tools are just like apps. You have to just click on and operate it. And now they have apps even for from a mobile also we can operate it. Okay, so this is the small intro about MATLAB. So before going into it, any engineering problem, not only engineering, it may be from any field. Why do you want to do simulation? What is the need for doing simulation? Say you take an aero system, like aerospace system, you take any tank system, or you take a motor, or any mechanical lathe, or anything, or management people are there, they want to just see what is the admission in an engineering college, like what will be the future engineer admission, anything. Why do you want to do some analysis or like simulation? What is the need? You want to optimize it.
Reduce the productivity.
Productivity? You want to increase the productivity, might be. Anything, say, if you take any machine or you take anything, mainly why do we do simulation is, say you have a power system, a grid is there. Now we say it as a smart grid. You have number of solar plants coming and getting connected to it. You have wind plants getting connected to it. So we don't know when a solar or wind plant gets connected to it, what will be the output. Suddenly we can't go and connect a solar plant to it. Sometimes there may be a blackout, the whole system may collapse. Or say you have a Mars mission, where you have to send a space shuttle, okay, and a satellite in the space, or you want to send a space shuttle to Mars. So we don't know what is the different conditions there, when to fire it, how to fire it, all these things, and what is the distance. So what we do a calculation, we do analysis, and we just predict a model. We make the model as such, how the original system will be, same way you will be making a model. Okay, and after that, you have to just simulate and see whether you can achieve that output or not. Mars mission, say in one particular angle, when it goes, it has to shift its axis and go it has to move in another axis. So at what instant it has to get fired, how much ignition has to be given, how much fuel it has to carry, all these things, what we do, we just predict it before. It's like we will do calculations, we do simulations. Once we do the simulation, we see the output. In that also it is not possible, is it? Once you see the output, okay, simulation is perfect. And can you go and send the space shuttle, or you can add a solar plant or something to the system? So then next step, what you have to do? Next step, what will we do? We have to make a small prototype of it. Is it? We will make a small prototype. Say you have a robotics. It has an application that it is a human, it's a human robot, and it has to do some thing like pick a glass and drink water, or something like bring water for somebody. Okay, so first of all, making a robo, and if you start doing it, sometimes a robo will come and catch your neck also. Okay, so it is a dangerous thing there. So what we have to do, first of all, we make a prototype. We just, the simulations or algorithms, we have already done it. We flash it into some hardware. We check for the particular signals coming, whether you're getting the corresponding output or not. Okay, and we just flash into the hardware and we make the hardware work there. Now the hardware is operating. Yeah, once the hardware is properly operating, we can just say it is a prototype. So once the prototype is operating properly, we can say that the same program, when it is implemented in any real system, that will surely work. Okay, that is the thing. So any simulation or anything what we are doing, the main thing is the end is a prototyping. You have to do a prototype. It's not that I do some programming, I see the output, I'm happy with it. It is not the thing. You have to go and end with a prototyping. So everything is possible in MATLAB. Not only MATLAB, you have number of softwares based on your field. Okay, you have LabVIEW, you have Multisim, you have Protex, you have many PSpice. You have a lot of software for engineering applications, mainly in electronics, electrical, mechanical, these fields. People can go for all these softwares. But one of the common software which is applicable for all these fields is nothing but MATLAB. So MATLAB, mainly if you see there are three, you can divide them into three things. One is MATLAB coding. You just write the code, very simple. You have already, I will just mainly teaching you each and every code. What I will teach you is from where can you learn these codes without mugging it or without keeping it in mind. When we do the programs, each and everything will not come to our mind. Only the logic we have to know. The syntax and everything is available in MATLAB. I'll just tell you where to go and search, how to see how to write the syntax, and how to proceed with the program. So I'll be just teaching you that. And in internet also, there is a very good source where all the IITians and NIT people, those who have done research, they have put their problem. So MATLAB file exchange, that is said to be the MATLAB file exchange. I'll just open that and also show you there all the fields. If you are doing an optimization, GA, genetic algorithm, PSO, and colony, or anything, BAT algorithm, every algorithm are already present. You need not go and reinvent which is already existing. Okay, and all, if you want some Newton-Raphson or Rangakutan or any algorithms, they're already existing. All type of codings are already existing. So these things are already there. Similarly, this is the coding portion. After that, next in MATLAB, you have something called graphical. Some people find it very difficult to go and write codings. For loop, if then statement and case structures and all these things put together, they get totally confused. Say they want to apply this on a motor for controlling the speed of the motor, or they want to apply on a tank system for controlling the water level of the tank, or something like this. Or you want to have a lathe and you want to control the position, or the position at which you want to have a cut or something. In these places, it is very difficult to write the coding. So what we can do there graphically, you have already a motor, just pick and put it there. You have a stepper motor, put it there. Or in electronics, you want an op-amp, just drag and put an op-amp. Instead of writing a code for op-amp, already an existing op-amp, you just put it. You connect all the elements, resistors, capacitors, you want to make an amplifier or whatever you want to do it there. Then it will give you an output similar to it. So that is a graphical way of implementing something. That is also very interesting. And people find it very easy in Simulink. That environment is called the Simulink environment. You have in Simulink number of toolboxes. You have toolboxes for electrical people, that is Sim power system is there. sim electronics. For electronics people, you have sim electronics. For mechanical people, you have fluid mechanics, or some other. I'll just show you. I don't remember it much. Then aerospace application, it is there. Then control system, you have control system toolbox. You have fuzzy logic, neural network, and even for optimization, and optimization toolbox is there, where you can use agentic algorithm. For PSO or other tools, you have to just download it from MATLAB File Exchange and just put it in the current folder in your MATLAB. Then you can start accessing it. So there are all these toolboxes available in Simulink, where you have made a space shuttle a system which represents a space shuttle, and you have number of algorithms written in it. Even the coding can be linked with these things. If you have written a algorithm, GA or PSO algorithm, that you want to come and put it in Simulink, that is also possible. You have a program in C or Fortran. You want to put that program here in Simulink, that is also possible using MEX files. So this is the second environment which is available with MATLAB. Third is stateflow analysis, that is also there. Apart from that, according to me, the third one, what I want to tell is hardware implementation. You can easily connect a hardware to the system. You can just test it. So you have a number of hardwares. I've worked with DSpace, I've worked with OpalRT, microcontrollers like Arduino. So these, like say if you take an OpalRT or a DSpace, connecting it directly here in this thing, in the studio, it is a little difficult. So I've brought an Arduino, a microcontroller. I can just show you how to create a graphical user interface and connect an Arduino to it. Okay, a simple thing. Arduino is a very cheap instrument, which you can say a controller, you can say, or you can say a data acquisition card, DAC card. As a DAC card also it will operate. So there you can just simply connect it to the system easily, and just the signal which you are generating inside the computer, you can bring it out using this Arduino. So that the two sessions are there. So first session, I'll be just starting with basics of MATLAB, simple MATLAB, we will say. See now, first I'll be just showing you what are the different commands and everything to become little familiar with MATLAB. The next step, what we do is, I will just tell you where are the sources already available in the demos or in the functions, how to find it. That will be the next step, where how to learn it, how to learn MATLAB. So that will be the second step. Then we will go into Simulink environment. I'll just take a simple example and show you what are the different things possible in Simulink. That is some of the basic concepts which you have to know. So the example, you need not worry. It may be a simple example which is common for all the field. That example is not what I want to say. I will be just telling you some concepts which you have to learn in Simulink. And then lastly, we will just connect a hardware and see the output. So this whole two sessions which I'm going to cover. Okay, so first of all, just let me show the screen, MATLAB screen. I think all of you can see a screen here. So this is the MATLAB 2015A I have put. This is also app based. So you can see here, it is just like different applications. Here apps are there, like for curve fitting. One second. So these are just like different apps here. So in case of MATLAB, mainly the main windows are, you have a command window, you have a history window, and you have current folder window. So these are some of the windows which are available in MATLAB. I'll be just showing you. I just want to enlarge it. So I'm just... So here you can see, this is MATLAB 2015 version, and you can see the different apps, like say in the apps when I went, it is curve fitting, optimization, MuPad, PID controls, all these apps are there. And this is the command window. You can see here the command window with the prompt here, command prompt. Here you can see an f of x and two arrowheads here. So this is said to be the prompt where you will be writing the command. So this is the command window. This is the current folder. You can see here in current folder, always the program which you write should be, that is, program should be saved in a location which is not the bin of MATLAB. So you can see here, see this is the program file C. This is the current folder now, which is the MATLAB folder, and which is the bin here. You can see the bin here. One thing you have to remember, don't keep any of your program when you're running in bin. It will give you an error, because whenever you're running a program, the main thing is it will be creating some supporting files. So it will never allow to change it will never allow to change the original MATLAB location. So if you run your program in bin, it will show you an error always. So what you have to do, you can go in desktop or in any C drive or something, you create your own folder, and that folder will be your current folder. I'll be showing you when you do the program, you will understand it. So this is about the current folder. Okay, and after that, say this is the workspace. You can see here the workspace. So here, if you see, workspace is a place where all the variables are defined. Okay, whenever you define a variable, like whenever you declare a variable, here, one of the advantage of MATLAB is you need not declare any variable. Say in case of C program, what you have to do, each and every variable you have to declare it, is it? If it is a number, you just declare it as a double, it is an int. If otherwise, if you're writing some name or something, we declare it's a string. Okay, you have to declare the variable. But in case of MATLAB, you need not declare the variable. Just give a is equal to 10. It automatically it will take as a double. Okay, or it will take it as an int according to its like how it understands. It will take that. It will define by itself. You need not define the variables in MATLAB. And in MATLAB stands for Matrix Laboratory. Okay, the word MATLAB stands for Matrix Laboratory. So here you need not define any variable, and all those variables which are given, it defines itself as an array. It will take itself as an array or a matrix form. It takes it in the form of a matrix. So we will be seeing all these things step by step. I'm just giving you an intro. So here next you can see the command history. So command history is what all you type in the command window. So here this was the command window. Okay, you can see here, this is the command window. So here, what all you type there, it comes in the command history. Okay, so what you can do now, say today you have done the program, you have closed and you have gone, you have just switched it off, and again you're turning on MATLAB. So all those you have used will be in the command history. You can retrieve it. Okay, so this is the command history. From command history, you can even create a whole program. That also I'll be just showing you. Okay. This is the command history. So these are some of the windows which you have to remember in MATLAB. So as I already told you, one is the current folder here. One is the workspace, which you can see here. One, the MATLAB command window where you can type all the instructions, and you have the command history. In history, say, which is already there. Say I'm just double clicking on this history. That will come here. Okay, and the same thing, I am just again calling the same variable. Just I put up or down arrow. If I put the previous command will come. I'm just taking the semicolon. If you put a semicolon and click, the answer will not come here. It will not show you the answer. But you can see in the workspace. See in the workspace, this x, here x I given 0:0.1:4 I have given. That variable came here. It is 41 double. Okay, 41 variables are already here. I'll just show you how this 41 came. It is automatically declaring it as a double. Okay, it is taking it as a double. So here, how this 41 came, that is, you can see here x is equal to 0.14. In the sense 0 to 4, in the step of 0.1, it will set 0, 0.1, 0.2, 0.3, like this till 4 it will do it. So in order to see that, the same command I have again put, and let me take the semicolon and I have put it. So it has created this 41 variables. See, column, in the form of a column it creates 1 through 6 variables, then 7 to 12, 13 to 18, it goes on like this. Okay, so this is, I just wanted to bring it back. So here you can see the 41 variables are created here in the workspace. So when I double click on this X, Now I'm double clicking on the X, and Excel sheet will open. Okay, so here you can see the variable X which was created here, an Excel sheet is created here, and all the 41 variables come here. All the 41 variables come here. So if you have any data, so for neural network or any other thing, you want to train a data, you have already having a very good set of data. That said, data also, what you can do is you can load it, import data. You have an option to import data for any Excel format. Okay, any Excel format can be imported, so you will get the data here. When you import it, automatically it will come in the workspace. So now with that data, you want to draw a graph or something, you can draw it. So now say I'm just selecting the whole data. I have just clicked on this one. So my row data fully was selected. Now I got to the plot. You have an option for plot here. Just draw the plot, bar plot or area plot, whichever plot you want. Automatically, when you click on it, it automatically creates a plot X command here, and it plots the graph for you. So this is a figure window or the graph window. Okay. So what you did, you had a data, you just loaded it. It may be the data of what you have already collected of some colleges, like students, number of students, or anything, any data, or sometimes some electrical, mechanical people, they would have done some experimentation, and you would have collected the data in the Excel form. So that data you want to draw a graph, directly import it and bring it here, as I have told you, and just click on the plot. So what I did, once again, I'll just show you. When I gave a command, automatically X variables was created. That variable I double clicked, I got the variable here, and I just clicked. If it is a column, you will be clicking on this one. Here it is a row, so I have clicked here. And if whatever, say if I want a bar graph, just click on the bar graph will come. Okay, this is how you do it. Now again, what you want to do, if you want to edit this, you want to have labels, X-axis, Y-axis, you want to give some name, all these things are possible. So for that, you have to go to the edit, okay, and go to figure properties. So you have something called figure properties here. So click on this figure property. So this window will open. So once again, I'll just show you. It is very simple. I have just clicked on this clicked on this data. I've just clicked the plot. So my plot will come here. So my plot is here on the screen. So now what I did, next step, what I want to do, I just want to edit this. So I will just go to edit and figure properties. So my figure properties will come. Now if I want, say this background is gray color, I click on this background and change it into white. So if I click, it becomes white background. Again, I want to put axis. So I'll just right click, grid on. So my grids are there. If I want to change the shape of the grid also, I can just go more properties and I can just make the grid dotted or anyway. Now if I want to change the color of this, just click on that, go to this color, change it into red. And if I want to change the thickness, I can just change thickness. I want to make it dotted, I can make it dotted. Anything what you want to do, you can do it. Click on this graph. If I want to change the font of these numbers, go to font here and just make it bold. And if I want to change the font size, I can make it as 12, 14 or anything, whichever I want, so that this is also thing. And I can click on this graph. If I want to make it a little more small, I can do it here. Then if I want to add label, so right click on it and legend. I want to add legend. So just add legend. So here you can see that this is the data. If I want to give a name for this data, say this is voltage or something, I can write it is voltage. Okay, so whatever things you want to do it here, you can write. Click on this again. Now you want to give X-axis, Y-axis, X label. I want to give it as time in seconds. So I can just have this time in second here. You can see it is written here. Similarly, Y, I just wanted to write it as voltage in volts. Okay, so that also comes here. So what all changes you want to do here, you can do it. Then you can take the snapshot of this and you can go and paste it in the Word. So it is very simple. This is for already existing data. which is already there. I have just shown you, or which you can import and you can bring it here. Okay, so this I'm just closing it. Now let me go to a PPT where step by step, like now I think you got a small intro about the windows which are available. Let us now go to the PPT and I'll just show you the different syntax available in MATLAB. So first of all, we will start with the syntax, simple things. Then we will go into the MATLAB environment and we will see each and everything. We are just going to see the MATLAB and Simulink. Okay, if you have any doubts, you can just clear it then and there. Okay, so this I think you can see the MATLAB Simulink PPT. So first of all, I just told you everything. Once again, we will just rush with different concepts. MATLAB mainly stands for Matrix Laboratory. As I already told you, MATLAB stands for Matrix Laboratory. It's a product of MathWorks USA. And this software package is mainly for numerical, scientific, and engineering computation purpose. It is for, yeah, yes, anyone is having a doubt?
Yes, ma'am. Actually, I have what is the possible for that? This is a single line of multiple then what is the possible for that?
What? Excuse me, I couldn't hear it. I think you can remove your external mic. You don't use your external mic. You just come to your laptop or computer where you have your mic. That will be a little more clear, I think.
Ma'am, I want to draw multiple line graph.
Yeah.
Then what is the possible for that?
Yeah. Don't worry. I'm coming to all those things step by step. I just wanted to give you a small intro of these, how it looks. That is what I did. Everything is there. If you want to draw subplots, that is also there. If you want to hold a graph, let's say already you have drawn, you have to multiple graphs, or how to use line command and you have multiple graphs. Everything is coming step by step. Okay, I will start from array. What is matrix? Because many people are there who don't know even simple things. So I'll just start and come. Don't worry. Okay, multiple graphs also I'll be showing you.
Okay, thank you.
So at the end, like if you have, again, if you have a doubt, at the end, again, we will come back to that. Okay, it is there in my PPT. So you will be for multiple graphs also, and even multiple in the same graph to drop subplots also, we will be doing it. Okay, so it is like, say, this software, it is a product of MathWorks USA, and this package has numerical, scientific, and engineering computation. Mainly we use this software for these purpose and for visualization also. So mainly the MATLAB, MathWorks product, if you see, you can divide them into 3 groups. One is the MATLAB for computational language, maths and visualization. For Simulink, that is graphical modeling. I already told you, for prototyping or you want to connect a hardware, you go for Simulink. And one more thing, state flow analysis is also there. Okay, so this state flow, it's a very powerful thing. So whenever you want to, like say, whenever you want to represent a system, how will you represent a system? You have a system and you want to represent it. You either have a transfer function of it or you have a state space, like you have a state space model of it. Okay, so state space model, the advantage of state space model is you can have intermediate analysis can be done with the state space model. So in case of transfer function, only the input output relation. What is transfer function? It is the Laplace transform of output by Laplace transform of input. Okay, so whenever you have a motor or you have a plant or anything, there if you want to do with the transfer function, if you want to do an analysis, it is very difficult because in transfer function model, all the initial condition we keep it as 0. And only for linear time invariant system, you can do this Laplace transfer function model. But state space model, you can do it for variable systems, MIMO system, multiple input, multiple output systems, and their intermediate analysis is also done. And their number of models are possible. That also you will be coming, like we'll be seeing into that. State flow analysis. Another analysis is state flow analysis. That is also there in MATLAB. Mostly we don't go for state flow analysis much, but when you want to do complex or in PhD level, when very high level computation, you go for state flow models also. Okay, so now why do we use MATLAB? So that also I've already told you, in C and other languages, you have to declare the variables. You have to specify what is the data type, and you have to allocate the memory. But here in MATLAB, you need not do all these things. It is automatic. You have to just give the variable within like value, like you have to just define the variable. Defining is also not here. You have to just write A is 10, or you have to give an as in the form of an array. Automatically, it will declare the variable, it will specify the data type, and it will allocate the memory also. So that is the advantage of this MATLAB. And here, this package, if you see, it's built. It is mainly built on LabPAC, that is linear algebra package written in Fortran. So an older Fortran language, the back end, if you see, all these programs are written in Fortran and BLAS, that is the basic linear algebra subprograms are used for writing these MATLAB at the back end. And it provides, like if you see, it is an interactive, like what are the things it provides? If you see, it is an interactive environment, and it has hundreds of inbuilt functions for computation. And then if you see, 2D and 3D graphics and animations are possible. Are they all like cut ho gaya? सब सेंटेंस कट हो गया. So sorry for the interrupts, like got cut. So here for 2D and 3D graphic animation also you can use, and there are several toolboxes. I already told you, fuzzy logic, neural network, image processing, signal processing, all toolboxes are already available, where all the functions are put into one toolbox so that those functions you can use. So toolboxes also I'll be showing you. Okay, and it is easy to use. And shallow learning, that is, you don't want, the learning is very simple. That also I'll show you where to learn and how to learn. That is also very simple. High computational speed it has, and it supports all the like operating systems like Windows or Unix or Linux, any operating system this will support. So that is the advantage of MATLAB. So here, as I already showed you the MATLAB, like you will be having an icon in the desktop MATLAB. So you have to just double click on it. The icon looks like this. The window will open. Or you can and if you want to quit this MATLAB, what you have to do, you have to go to File, Exit, MATLAB, so you can quit it. Okay, so this will be the MATLAB window, which already I have shown you. The same window is here. And MATLAB windows, if you see, mainly there are three main windows. One is the command window, graphic, figure window, and edit window. So this also I already showed you. Command window is the place where you wrote what is the X value. Graphic or figure window, the graph came in the window, that is to be the graphic window. Edit window I didn't show you. Edit window is nothing but the M file, where you create the M file. So that also I'll just show you 1 second. So here, say this is the MATLAB environment, and I already told you here this is the command window. In command window, when you write the program, you get the answer then and there. Okay, you saw the answer there itself. Say now I have written a program and I am clear. Okay, my program is full and I have sequence, you have done it properly. Now what you can do, you can create your own function, or you can create your program there. Now you can put all those functions together and create your program. So all those things which you have already written here, it is in the command history. So say I declared a variable X, and after that I plotted this X. Okay, so what I can do, I can just select these two. I have selected these two. Just right click on it and I just give create script. You can see an option here called create script. So just click on that create script. Automatically this M file is open. Okay, this is a program. So this only 2 lines are there. I can even show you for bigger programs. We'll be seeing it later. So here you can see, so our one more program I'll just show you. This is a program to draw a stem. Okay, so here X value and Y value is defined, and this program. So X value is defined, Y value is defined, and stem is a command to draw a plot. So I'm just right clicking on it, create script. So automatically this is an untitled script file created here. Now what you can do, run this. You can just go here and run it. Okay, so once you run, automatically it will give you the thing. Or what you can do, you can go here to save, and you save this as some so now the extension is .m file. Okay, you can see here the extension of this is .m file. You can give any name to this and save it. So let me give this name as my example1, exp1, and I shouldn't save it in bin. Okay, it is better you save it in some other location. I am just saving this in my desktop, and I am saving this. Okay, so now what I have to do, I have to go to this desktop. Okay, desktop current folder. How will you select the current folder? I am telling you. So here there is a small folder here. You can see that symbol. Once again, I'll just enlarge and show you. This is the symbol here. The browser for folder it's given. No? So that is the symbol. So that, just click on that. Okay, and just choose desktop. Select folder. So now what happened? You can see here, see user Shimmy desktop is my current folder. My bin folder has gone. Okay, so now what you can do, you can just go and run this program. So here if you see, I saved it in the name exp1. So that will be, say, this exp1 is there in the current folder. Okay, so now you just go and run this program. So automatically, see, I didn't write here exp1. So that is a function now which is being created. So, or you can say that is a program which I have saved. So automatically it is called here, and this program is here. Okay, so here in this, one option is you'll write X and you'll see what is the value. Then you'll write Y and you'll see what is the value there. And then you write the stem and you just plot the stem command. So that you can one by one, you can write it in the command window and you can do it. Step by step, you can do it. Okay, these command stem and all I'll be teaching you later. Just I want to show you what is M file, creating an M file. So in command window, you will get the answer then and there. Okay, so you are writing a whole program. You want to see whether you have declared the variable correctly or not. There should be 100 constants. So you are writing it. You are not clear that whether your program will create that or not. So what you will do, you will just write the program there and check it. Okay, it is clear. Then you go to the next step. When the whole program is clear, now you will go to the command history. What you can do, select everything and create a script file. Or if you want to go and write a script file directly also, what you can do, you can just go to home, there, new script file. The option is here. You can see here, if you go to home, new script file option is here. Okay, so you can write that also. You need not go and write it in the command window. You can go open the script file. Script file will come here. So let me write A is equal to some 12 and my B is equal to some 45 and C is equal to A plus B. So this is a small program I have written. What I can do is I can just save this as my program. Okay, let me save it. I'll go to the editor and save this program in some name. You can save it as sum123. So like sum is a inbuilt function, so sometimes it will not allow you to save it as sum. So I write sum123 and I'm just saving it. So again, it is in the current folder. Now you can run this program. Automatically, you can see the sum here in the command window. Okay, sum123 is called and C is equal to 57. Okay, so it is not necessary that you have to write it here, go to the command history and do it. You can directly go to home, new, and create a script file and write your whole program. Okay, step by step, we'll see how to write program. So this is only simple things I am teaching you. So next, these are the different MATLAB windows. Okay, so this edit window is nothing but the M file which you created. So that window is said to be the edit window. So here again, this is the command window. This is the figure window. and this is the workspace, and this is the edit window or the .m file where you will be writing the program. Okay, so next is command window. In the command window, that is the main window, you have this prompt in this where you write the program. And graphical window, that also I have shown you. Edit window, that is M file, that we know it. Sub window, so the history window, I showed you the history sub window, and the workspace also, you know, that is also a sub window. Okay, so here the command histories, this also I already showed you how to like go to the command history and create an M file. That is also over. Okay, so create an M file, this is also over. Workspace is also over. Pop-up menu, right? Yeah, this is also okay. So now we'll go to the file types. There are different file types, mainly in MATLAB. If you see, M file, MAT file, and MEX file. 3 types of files are there. M files, what I showed you now. In the edit window, when it gets saved, it comes as .m files. MAT files, when you have a data, say in X was a lot of 100 or 41 data was there, that gets saved as a binary data. So that is the data in workspace which gets saved as binary is saved as .mat file. So this data mat file can also be again loaded and you can use it. Next is MEX file. MEX file is, say, whenever you have some program in C or Fortran that you want to bring it here, you convert it as a MEX file. You just write the program, you change the program, everything with MEX, and you save it as a MEX file, and then you will be calling it. So any C program or Fortran program, when you want to run here, you have to convert that as a MEX file, and then only you can run it. Okay, so you have procedures. I'll tell you where to learn all these things. So you will get from MATLAB File Exchange. I'll just show you the locations. So this is about the file types. So first is the M file, that is the script files, and the function files are saved in the form of .m files. That is ASCII text files, you can say. They are standard ASCII text files. Next is MAT file. So these are the binary data files and have .m file extensions and can be loaded by using the load command. Okay, so using load also you can load it. So any data in MATLAB, many data are already loaded in their in the C prompt, like in the C program files. Already number of examples are there, they existing. If you want to load it, the command is load, and those those datas are in the form of .mat files. Okay, next is MEX file. As I already told you, these MATLAB callable Fortran or C program files, they are said to be the .mex files. So here it's a small example. It is showing where MEX setup. Please choose the compiler. It will ask you. So here actually I don't have this compiler, so I'll not be able to do it now. So this was a Hello program which was already written here. So you can see here hash include mex.h is done, and then you have to write the whole program. And once you just run it, mex hello.c, when you're calling this M file, which was, the MEX file, which you have already, .c file, I'm sorry, the .c file which you have written, you call MEX hello.c, automatically it will give you the answer. So this is how C programs are usually called. Okay. So next is commonly used commands. Some of the commonly used is clock. When you write clock on the command window, that is the command prompt, automatically it will provide you the clock time and date as a vector. Okay, and date provides a string, and then version VER, if you give, it gives you what is the version with which you are working. So this PPT I'll be giving you, and it will be there in my slide share also. So you can just go and work with it afterwards. Okay, so I'm just, some of the things which are not much important, I'm just not writing it. You can just try this. Next is PWD, that is it provides present working directory, then CD to change the present working directory, DIR to list the files bar folders, MKDIR, make a directory, you can write it as MKDIR, then LS, that is list the files, then path, display the MATLAB search path, then edit path, copy file. So see, copy file is a command to copy. It copies a file. So these are some of the command. Who, if you give, it lists the variable currently in the workspace. Who's same as who, but gives more information such as type, size. Then what gives you the list of .m files, .mat files, and .mex files on the disk. Then clear all, that is the command used for clearing all the variables in the workspace. Clear x, y, z, that is if you want to clear a particular variable, you will give that variable name there. Mlock function, that mlock function is used to lock a function so that you will not be able to delete that function. CLR, that is clear screen, and CLF is to clear the figure window. So these are the different commands there. Then Control C, that is stop the execution of a function. When you want to quit MATLAB, you write quit, and or you can even the same thing, exit also. If you go to the file in MATLAB and go to the last thing, exit, one option is there. If you go, it will exit MATLAB. Okay, help commands are help. If you write, it will list all the topics there. Then help topic is there. Look for string, that is also there. Help win, that is open the help window. Then help desk, open the web browser. Online help, then demo is there to run the demo program. Okay, and coming to the variables, variable in case of MATLAB, if there are 14 fundamental data types available, or classes you can say. So these are the things you can say. Data types in MATLAB, so it is always, I already told you, it is given in the form of an array or a matrix. So you have characters, numeric, cell, structure, Java classes, and function handles. So in numeric, if you see integer 8, int 16, int 32, single, uint 8, uint 6, that is unary, int 16, uint 32, double, spas. So these are the different data types available. So here, what is a cell? If you see, say already the int, double, and all, you have already seen cell. So cell is used for storing dissimilar kind of data type. Okay, one can store array of different type and size. So here you can see A is 1, 2, 7, 8. Okay, so it is an array which contains 1, 2, 7, and 8. And B, if you see, it's a matrix. It is a 3 into 3 matrix with 1, 4, 5, 6, 8. These are the elements of the matrix. And one more C variable is defined, which is zeros 2, 3. The sense 2, 3, like 2 rows and 3 columns, zeros. It will just create 0, 0, 0, 0, 0, 0, like that. C is there. So now D underscore cell, when you want to create a cell within parenthesis, if you put A, B, C, A, B, and C are cell arrays of different data type. These are the of different data type and size. Okay, so these together you can put it in a cell. So I'll just show you. I'll just copy this. Here, first of all, let me call the first thing A. Okay. Excuse me. So here you can see the A is equal to 1, 2, 7, and 8 I've given. I'm just taking the colon here at the end and I'm just clicking. So you can see A is equal to this. It will automatically give you an array 1, 2, 7, and 8. Similarly, let me take the next variable B. So here B, you can see here when I gave B, 1, 4, and 5 are the first row. When I want to go to the second row, again I have put here a colon. Okay, again 6, 8, 9, again a colon. And again 9. So there are, it is a 3 into 3 matrix. So otherwise, say you can even like say if you want to give an array and you want the array to be a colon. So what you can do, one thing is you can transpose A. A transpose, if you give, automatically the row becomes a column. Or otherwise, what you can do, you can just give comma, like 1 comma, like in two types, 2 ways you can write this matrix, array, 1 comma 2 comma 7 comma 8. That also gives you the same way. It's not a problem. If you want to convert a row to column, you will be giving it transpose. It will automatically convert to a column. Okay, so here again A transpose I am giving. So automatically if A is in the form of a row. Already it is in the form of a row. So when I give A transpose, it is giving me the transpose of that. Next, C. I just want to see C. What is C? C is zeros. So you can see here, C 2 comma 3, so it gives 2 rows and 3 columns, 0. Now I'm just creating a cell. So I can see here D underscore cell. So here D underscore cell, if you see, it is 1 into 4 double matrix, the array, then 3 into 3 double array matrix, and a 2 into 3 double matrix, which is coming inside this cell. So if you want to access a particular cell element, you say first element I want to access, I can give this command, that is D underscore cell 1. Say D underscore cell 1. So the first element in this cell, that is 1 into 4 double matrix, so that will come. Same way, if you want to access the third one, you can just give 3. So automatically the last element is there. Okay, so this is how you will be accessing the cell array. So next is structure. So structure is, that is also a data type used in a similar way of cell array. But here, if you see, here you have the string type. So you can see ABC dot name. You want to give a name or a string. So different. These are also different data types only that can be put to a group there. So here it creates a structure named ABC with 3 fields, that is name, roll number, and sex. And many sets of values may be assigned to these 3 fields. So many values also you can assign. So this program also we'll just try now. So here the first one is ABC name. So I'm just giving the first is, I'm just writing ABC dot name. So it will give me ABC. Name is nothing but Shimi. So next is the roll number. ABC roll number is this. So the ABC roll number is 903. Next we had the sex, that is female. Here, if you see, sir, ABC is a structure with name Shimi, roll number is 9076, and sex is female. Okay, so this is how you create a structure. So coming to the different operators. So I'm just not going any, I'll just show it here itself. So the different operators, if you see, MATLAB operators can be classified mainly into 3 categories: arithmetic operators, relational operators, and logical operators. Okay, so the arithmetic operators are that like addition, multiplication, all these things. Relational are greater than, less than, equal to, and logical, you know, and, or, and all these things are the logical operators. Next, so you can see here the arithmetic operators. So here, these are the arithmetic operators. I think Fi is not working. Anyway, arithmetic operators, you can see addition, subtraction, multiplication. The symbols are given here, and it is a known thing. Arithmetic operators, you can say plus, minus, multiplication, division, addition. Okay, for power. And this is how you just represent it in MATLAB. Then relational operators. Relational operators, you have less than, greater than, equal to, almost same. Not equal to, it is a minus and equal to. If you put, it is not equal to. So here you need not keep all these things in mind, because in MATLAB you can just go and in help, if you see, all these functions will be already existing. Logical operators, if you see, if you just go to the help and put logical operators, all these operators will come. So you need not remember it. Ampersand is for and, or like it's not one, it is a line, straight line, and then you have not symbol, then XOR. So these are the logical operators. Then the hierarchy at which it operates. Okay, so the hierarchy is, if you see, hierarchy of operation first contains contents of all the parentheses within the bracket. What you have put, that will come, are evaluated first, and then it goes into the inside the parentheses. For transpose, then power, then complex conjugate transpose and matrix power, then comes the unary plus, unary minus, and logical not operation. Then comes the multiplication, right division, left division. So in right division is, if it is say a dot slash b you have written, that is right dash, then a divided by b it will do. Or left division, a dot left division b means it does b by a. So the division, the slash what you put is also very important. If you put towards right, what will happen? The first variable divided by the second variable. In left division, the second variable divided by the first. So in multiplication, according to the division what you give, that also division comes, then dot division, then comes the multiplication, then matrix, right division, left division, addition. So dots multiplication is nothing but the array multiplication. The another one is the simple multiplication. Then addition, subtraction, colon, then less than, all the less than, equal to, these symbols come. Then at last the logical AND operation, and last the logical OR operation. So this is the hierarchy. You have the, and this is how it operates. Then you have the built-in functions. So there are a number of built-in functions available. Besides the simple arithmetic operators on variables, a number of built-in functions like sign, absolute, if you want to find ABS, if you want to find the square root, SQURT, EXP, exponential, log, so Bessel, gamma, all these functions are already available. How will you write? Function and give the function name, like function, then the function name, and then the variables. You will just write the variable. If you want to find the square root, you write square root within bracket what variable you give, automatically it will find it. So if you want me to show SQRT, square root SQRT of 16. If you write square root within bracket 16, automatically your answer will come. So this is how you just do the functions. So you have to just write the function name, that is square root or whichever, and give the variable name. Sign you want, sign, all those things. Next is complex numbers. So if you want to write a complex number, you can write it in all these three forms. Say x is equal to -4 plus j star 8. That is also you can write -4 plus 8j directly also you can write, or 8 cross j. Okay, so 8 multiplication symbol j. So these three, if you write, it creates complex numbers. So I can just show you that. So you can see here x is equal to -4 plus j8 is written. So anyway, in all the three forms which I showed, you can write. If you want the real and imaginary part of that, automatically you can okay, so first you want the real part, so automatically -4 it's given. Imaginary part, say x underscore image is equal to imaginary part of x, -4, and the imaginary part was 8. Okay, so these values you can bring it. Once again, I'm telling you, don't get worried. I'm showing you a lot of functions and all these things. At last, I'll show you a place where you will get all these things. Okay, there you will be finding, okay, this is very simple. You need not worry. I'm showing you a lot of things, and it is not, it is very difficult to remember all these things. Suddenly in square root, you use some other software, so suddenly you know what is the command. You need not worry. You can just go and search for it. You will get the syntax, everything you will get. Okay, that also, first of all, I'll show you so that you will get little more confident. So here, this is the MATLAB window. Can you see a small f of x here? You can see here a f of x here. So this is a place where you can get all the functions. Okay, so just click on this. So what will happen? A window will open, and there all the functions. So in mathematics, or in Simulink or in all the toolboxes. All these things are already existing. So here you go to MATLAB, Simulink, and all these things are there, or in MATLAB languaging. So mathematics, we are seeing all these mathematics and graphic functions. So in mathematics, if you see again elementary mathematics, linear algebra, or random numbers, or whatever things you want, you can just go into this. So say if I want to go to the elementary mathematics, arithmetics, again plus, addition, unary, plus, minus, all these things are existing here. Okay, so here this window is not coming. वहाँ ही आएगा, नहीं यहाँ भी आता है.
नहीं वो I think ये कई बार ना जो
स्क्रीन शेयर नहीं किया. हाँ नहीं, सर के लिए डिफिकल्ट होगा ना, सर को दिख नहीं रहे, यहाँ से मुझे भी नहीं दिख रहे.
मैम वो कई बार है ना, ये वाला जो सॉफ्टवेयर है वो फिर दोनों जगह प्रेजेंट नहीं हो पाता. सर आप यहाँ आ जाएंगे तो
मैं अभी देख रही थी कि दिस इज नॉट डिस्प्लेड हियर. ओके, सेंटर्स को जा रहे हैं, बट वही है कि सर के लिए यू कैन जस्ट पुट योर चेयर देयर एंड सिट इन फ्रंट ऑफ दैट इटसेल्फ. You can come here also, otherwise you can come here, you can see in my system itself. You can put a chair here. Rajana. It's not a problem. Okay, so here if you go like once again I'll just tell you, so you have an f of x here, just click on this f of x, you will get all these things. Say this was like this, so you have the MATLAB, all the different MATLAB languages, mathematics, elementary, whichever. Say optimization toolbox, I want to see what are the commands in optimization, I can just go, or mathematics, just go into mathematics. If I want to see graphics, how to plot, so 2D plot or 3D plot, just click on that. And I want line plot or polar plot or whatever plot, line plot, click on that line plot. I want the plot command, or I want to draw command plot yy. That yy, what will happen is it will draw the plot with two y-axis and single x-axis. Okay, say for example, you have a plot where you want to plot the voltage and current. Voltage is 230 volts and current is 0.2 amps. Both of you, if you put in the same y-axis, what will happen? The current will not be seen. It will be near the x-axis, 0, and y will be more. So I can just show you that. Say for example, you are just drawing a plot like this. One is the voltage plot. You have just drawn the voltage 230 volts and current is very less, 0.2. So this is 230. Here it is around 230 volts and current is very small. It is almost here. You will not be able to see it also. In such case, what you can do is you can draw a double graph where voltage will come this side till 230. Say voltage can be plotted like this. Voltage will come here and the other graph will come here. So this will be defined from 0 to 1. So your 0.5 or something, say your current value is 0.5. That also will be, your current is 0.5. So that will also be displayed here this side. So this is plot yy. Okay, so here you can see the plot yy. So whenever you click something, say plot command, automatically you will get everything here. Plot x comma y, plot line space, all the syntax are here. So you can see here, all the syntax are coming here. More if you want some examples, you want to draw that and see. What you can do, go to this plot 2D, go to more help. So in more help, it will give you everything. It will give you examples. It will give you the explanations and everything is available. So this is the place where you want to learn function. So you can see here, it is for 2D plot, just plot command. So plot xy, say example is given here, plot xy line space. If you want to plot multiple things, like say here, example is given here. So automatically you can see here. Somebody was asking me for double plot or multiple plot. I'll be just showing you again. But this is how, say, x is there. X is defined, then y1 is defined, y2 is defined, and y3 is defined. So what you can do with the same x comma y1, x comma y2, x comma y3, how you want that also. So automatically those plots can be seen. So that's why I said, whatever you want, don't get afraid. Everything is there. You want multiple plot, you want x this side, y that side, you want to make the plot upside down, you want to make a semi-logs, whichever thing, you just go and search here, you just search, you will get it. And there are other places also where to search. You have help window. This is one place you want to search, you can do it. One more is the help window. I'll just give you the help window. See, help window is there in the home itself. Here, help. Go for documentation or example help. Example also you can go to documentation. Everything is here. You can see here. MATLAB, Simulink, Aerospace, which help you want. All these demos are already existing. So if I want to go to MATLAB, go to MATLAB. In MATLAB, again, same, getting started, how you want to start, each and everything is given here. Even video tutorials are there if you're connected online. So tutorials for all these calling function, 3D plots, 2D plots. So this is for, say, example, I choose for 2D and 3D plots. So one by one, simple things, they have explained everything. X is equal to 0, pi by 100. You can see an example here for drawing a simple graph. So just what you have to do for learning purpose, that's what I said, when you want to learn, just click on this, copy, Control C, and just paste in your window. So you will learn, okay, how this plot came. Now you don't know how your X and Y is defined. What you do, just up arrow. So first of all, you will get the X variable. Just take off the semicolon there. Okay, sorry, semicolon, and just click on it. So you will understand how these variables are defined and what steps. So it's a very big thing. See here, if you see 0 to 2 pi. Okay, pi is 3.14. So 2 into 3.14. 0 to 3.14, 2 into 3.14, and pi by 100. 3.14 divided by 100. So 0.0314. So in that steps, it has created the X variable. Then Y is nothing but sine of that X. So you can just put, after this, just take the Y variable. Y variable, you just up arrow, you get sine X. So now if you see, all these sine of those X variables are there. Okay, so this way, step by step. So go to the example, whichever example you get, you just copy it and do step by step and learn it by yourself. MATLAB, it's very easy. One thing what you have to do is you should have that capability to learn. Everything is available. They have given step by step each and everything you have in this. And what I am showing you also, I have just taken from these help only. So there is nothing. Got stuck, I think. एस्केप नहीं, मैंने एनलार्ज नहीं किया वो कर्सर, वो कुछ और कर दिया तो ये प्रॉब्लम हो जाएगा. Okay, so now again we will go to the I'm showing this one, I think. Okay, so we were seeing the built-in functions we saw, then we saw the complex numbers. So I told you complex number also. Then after that, in complex functions, complex numbers, you have a number of other functions like square root. If you want to find the magnitude, so if you want to find the magnitude, what you will do, you will write the square root of the real term square plus the imaginary term square. So that's the same thing. Or you can do absolute of x. If you put absolute of x also, it will give you the this square root, well, this magnitude only. If you want to find the magnitude, that is square root of x squared plus y squared, the same variable will give you the absolute. Angle, if you want to find angle of x, you can use a tan. When you want to find the arc tangent function can be used for finding the arc tangent. And then Cartesian to polar and polar to Cartesian, these functions can also be used for finding different complex, these are the different complex number functions. So these things you can try. Okay. Next is the assignment statement. So assignment is when you are just having a variable name. You can see a variable name is equal to the expression. So here circle underscore area is equal to 3.14, or you can write that pi into r, where r is the radius. You have to define the r variable before itself. R is equal to 0.5 or something, and if you give like this, this will give you the this is just for assigning a statement. You have to use the equal to sign. So these are different assigning statements shown here. We'll just see some example for assignment. So here, say you have a function given f is equal to a plus b minus cd by e the whole squared. So when you are, and a, b, c, d, all these variables are given. So when you want to write it in MATLAB, what you do, a is equal to 1, b is equal to 2, c is equal to 3, d is equal to 4, e is equal to 5, and you will write the function. So same thing, f is equal to a plus b minus c into d, you have to put the multiplication symbol divided by e, and for power it is the exponential symbol you have to put to the power, that is to square. You will be writing it like this. So okay, so this, just let me copy, Control C, and I have to just paste it here. Automatically say a, b, c, d, all these variables are there, and this was the function I gave, and automatically I got the function value here. Okay. So one more example is here. So for logarithm, when you want to find the log, similarly these things you can just try this. It is very simple. Then vector and matrix. How to write a vector or a matrix? So this is what I already told you people. Same way, when you want to have a row vector, you just p is equal to 1, 2, and see p is equal to 1, 2, 4. Or same way, you want to have a row vector itself, you can write p is equal to 1. So you can write it in this form also. So you can see here p is equal to 1, comma 2, comma 4. That also give you a row matrix similar to this. And when you want a column matrix, q is equal to, you put the semicolon here itself. Okay, when you put the semicolon after each element, automatically it becomes a column. Or what you can do, you define a row and put a transpose. Then in that case also, it will give you a column. Both are possible. For writing a matrix, say 4, 5 minus, say what you do, 4 and 5, one row you want, then you put a colon and then write the next row. So this will give you a vector or a matrix. Okay. So then next, some of the operations of vector and matrix, they are vector transpose you want to do. Then what you have to do, y is equal to x transpose. Then mean of x, it will give you the average of all the elements. The length of x, it will give you the number of elements in the vector. Maximum, it will give you the maximum value. Minimum, that will give you the minimum value. Product of x, it will give you the product of the elements of vector x. So these are the different commands that also you can just go through. There are more than 82 types, so I'm just rushing with this. Okay, so now matrix relation commands are there. I of n, 0 of n, ones, then size A, del, that is delta of A will give you the determinant of the matrix. Rank of the matrix, if you want, you can put rank of A. Then eigenvalue, if you want, you can put EIG of A. Trace of the matrix, that is the diagonal element. You want, you put A, trace of A. Then if you want the diagonal return, calculate the sum of the diagonal. So trace will calculate the sum of the diagonal. If you want the diagonal, you can write DIAG of A. Inverse of the, calculate the inverse of a matrix, you can write inverse of A, INV of A, plus 2. If you want to find the sum of two matrix, plus A comma B, subtract it, minus A comma B, you want to do multiplication, M times A comma B, and A colon, that will give you the transpose. That already we have seen in the other case also. So same way here, matrix relational operators are also, commands are also the same, almost same. Next is partial fraction. So you have a function and you want to find the residue for it. So first what you have to do, you have to define the numerator term, you have to define the denominator term, and then put residue of this. That will give you the, first of all, it will give you the residue. R will give you the residue. P will give you the poles, how many poles are existing, and K will give you the constant. So for one example, if you take, you'll understand. Say partial fraction of, we want the partial fraction of a function given here. S plus 1 divided by S cube plus 7S squared plus 16S plus 12. So now when you want to do the partial fraction, sometimes a constant may be there which can be taken out. Say if it is 2S plus 2, that 2 will come out as common. So that if such a term is there, K will be existing. Otherwise, K variable will be a 0. Then residue. Residue is that which comes at the top. Say for example, if there is a pole of 2 or say 1. So it is say 5 divided by some S plus 1 of the pole. I am not sure when we do this program we will understand. So this is 5, or you can say this like 5 is looking like S, so let me make it as a 6 or something. 6 divided by S plus 1. So here this is the residue, the one at the top, R, that is this R, and pole is nothing but -1. Okay, so for this you have to find the partial fraction. For that function, when you run that in MATLAB, Hmm. 52 था. Yeah. Oh, again I did this. ये आ रहा है, MATLAB नहीं आ रहा था ना. Flowing, say here in the previous case, when you write the command n is equal to 1 comma 1, because say numerator s, that one variable, and this 1, to all both the elements are 1 1, so numerator will be defining as 1 1. Denominator, how will you write? S cube is 1, so the s squared element is 7, 16 and 12. Now you have to write residue of numerator comma denominator, so you will get the answer. R is -2, 2, -1, so it is -2, 2, -1. Poles are -3, -2, -2, so it is a double pole here. Okay, so 2 is repeating, -2, -2. So that's why you will have it as S. When you write the function g of s, it is s plus 2 and s plus 2 the whole squared. Okay, and here, if you see, this is -2 is the residue and the pole is s plus 3. That is -3 is the pole. And k, there is no constant outside, so k is null vector there. So this is how you will get the polynomial. So I'll just write it and show you. So this one we let us take. Okay, so here if you see numerator and denominator, I am writing it, and then residue. So you can see here residue is R, P and K value have come. So R is -2, 2, -1, P is -3, -2, -2, and K is the null vector. So here I just define the numerator. So numerator term, if you can see here, n would have come here. Okay. So you can see here the numerator n is 1, 1. It is already defined there, and denominator term is also there. Since if you want to see the numerator again, you can just put n and c. N is the numerator and b was the denominator. Okay, so residue of that will give you the partial fractions. Next, we will see the polynomial. Okay, so polynomial, if you see, it is represented as a row vector again. It is entered with coefficient s terms in descending order. So multiplication, for multiplying two polynomials, you write convolution CONV of P1, P2, and given the polynomial P1 and P2, multiply them. So P3 is equal to convolution of this. For example, you can see a program here. P1 is given as S1 plus S2 and P2 is given S squared plus S2S plus 1. So as already I said, P1 will be written as 1. So S element is also 1 and then plus 1. So you can, this S element is 1 and here also 1, 1. So this matrix will be 1, 1. And P2, when you write here, this is 1, 2 and 1. So you'll write it as 1, 2, 1. So if you write convolution of P1, P2, automatically you will get the results obtained is 1, 3, 1. It will multiply. This is a convolution of these two and it will give you the variable like this. So when you want to again write it in the polynomial form, say it is 1 means s cube, here s squared, yes, and 1. So you get it in this form. So next is coming to the graphics, plot command. Okay, so two-dimensional plot. Already we have seen some plot. So when you want to plot a command, the command is plot of x comma y. So here x and y has to be first defined. So y is equal to x squared, where x variable, draw a plot for the equation y is equal to x squared, where x variables are from 0 to 10. So what you put, x is equal to 0 to 10 in steps of 1. So that is what is shown here. Your variable is 0 to 10 and you are just keeping the step size 1. If you want, you can keep it as 0.5. So it will take in the steps of 0.5. And y is nothing but x dot exponential of 2. That is, here it is matrix multiplication, because x is here as a array. So when you want to multiply with an array, like, sorry, not multiplication, exponential with an array, you put a dot here. If you want to do array multiplication, dot into that star. Okay, so star, that dot means that it is array multiplication, array exponential. Like each element it has to do it, and plot x comma y. Okay, so now let me take this very simple thing. We'll see a lot of plot commands now. So when I click it, automatically the figure window would have come. So this is the thing. So x is 0 to 10 in steps of 1 and y is the power. So that's why you can see a exponential curve. Okay, so this is for plotting two variables. Very simple. Now we will go step by step. Next is when you want to print a label. Okay, you want to print a label. Then to make a plot more understandable, the axes are labeled and title is provided on the top of the thing. So x label, then it will give the x variable. Okay, x label will be there. Y label of within parentheses, you give within the bracket and within single quotes, you have to write string, whichever string 2 is the second, say time. Then you have to write time, or say x-axis is time and y-axis is your voltage. Then you will be writing here voltage. And you want to give a title like VI curve or something, you can give the title. So you can just see a example for that. So here, given a better illustration for the same thing, x label and y. So it like say, let us take a small program where a variable, a is equal to 10 e to the power minus t for t is equal to 0 to 5. So t variable t is given as 0 to 5 and you have to a 10 e to the power minus t. So this is the program which you have to plot. Okay, this is one. So first of all, t I have to define. So what I have written, t is equal to 0 to 5 in the steps of 0.1. Okay, this is the first step I did. Then a is equal to 10 into. So here it is given 10 e to the power minus t. So 10 star exponential minus t. Okay, so t I have already defined. So you have to define the t, then only you can use it here. Then plot t comma a. Now I am labeling it. X label is time in seconds. Y label is within single quotes you have to give output. And title is plot of a is equal to 10 exponential this. Grid on, it will give you the grid lines. Okay, so now from here I am just copying it. And let me paste it. Here you can see t is equal to this, a is equal to exponential of 10 exponential of this, plot t comma a, x label, y label, title and grid. So let us see the graph. So here, so in the graph you can see here, this is the x label, you can see it. This is the y label, okay, output, what we have given. This is the title, plot this, and this is the grid lines. So you have turned on the grid line. So this is for a simple plot. Next is entering a text and plot. You just want to enter at a particular distance, you want to enter some. Say in this graph itself, which you have seen here, in this graph, at this particular instant, I want to write something on this graph here. Or for that, two options are there. One is you can write the text and with the coordinates, you can give the x coordinate, y coordinate and write the text here, or get string. And you can write the string name here, and you can just in get string, you need not define the x and y variable. You can, a cursor will come and you can go and click with mouse click, it will come. So we'll see the example, you will understand it. So here there is a simple example where we have to use get string y is equal to 3x plus 5 for x variable varying from 0 to 10. So x is equal to 0 to 10 in steps of 0.5. Y I have written 3 into x plus 5. Plot x comma y. Get string. It's a straight line. I want to write this. It's a straight line. And now I have to grid on. Label we have already seen. Title, all these things. So I'm just copying this. Okay, so now see the plot is there. The plot is, say, x-axis is here, y-axis is there. Get string, when I gave this, cursor will come. Okay, and this, it's a line where I go and click, there it will write. Say this is a line, I was just want to write it here. So I'll just click on this. So it will write it's a straight line. So that is getting a string at a particular location. In the same graph, if I want it in some xy location, that is also possible. So what you can do is, in that case, text 3, 10. In that 3, 10, I will be writing this, get this string. See here, I'm giving the single parenthesis. Okay, get this, it's a string. So x is 3, 10, it's a straight line. So what will happen? This automatically in. So here you can see this is 3, 10. It's a string automatically comes. So if you want to write something in a particular location, you can just give that location. Otherwise, get string. Get string is better because you can go and write it wherever you want it. Then axis control. So if you want to control the axis, you want to write x-axis should be from 0 to some 100. Y-axis should be from 0 to 2. That you can specify by writing the axis x minima, x maxima, y minima, y maxima. Within square brackets, you have to write that. And with this axis, it's a function. So you have to write it within curly bracket. So this is how you will be defining the axis. If you don't define the axis, it will take the default axis. So you can see here, for example, first we are just going to see this one. A is, here I have given the minimum value, the maximum value of x, minimum value of y, maximum value of y, and just writing axis of A. So for the same graph, say x-axis I have just defined as -3 to 3 and y-axis 0 to 10, axis of A. So automatically you can go and see the axis. So it has defined from -3 to 3 and 0 to 10. Okay, so this is how the axis of A is coming. Since I have not specified, if I don't specify, it will take the default. Next is, say, I can even write it in this form. I can give the axis like this also. So this is also a format where C, that is x-axis is minimum maximum you can give, y-axis minimum maximum, and you can write it. This is the syntax I showed you within curly bracket C and D. If I want to see it, C within curly bracket, then within square bracket C and D value if you give, automatically that also will give you the same. So it was the same thing. So it is coming the same. Okay. So next, if I want to redefine it, infinite and this is also a way where you can define the axis. Axis of -5 to 5 is the x-axis. In -infinity to 10 is your y-axis. So you can see the graph like this, -5 to 5, and this is infinity. -infinity, say it is starting, that's why it is coming in the center of the graph, and then 10 is the upper limit. So you can just define the axis also according to your requirement. And if you don't want axis auto, if you put command axis auto can be used to re-enable the MATLAB automatic thing. So if you put axis auto, automatically that will get re-enabled. So here you can see automatically it will come to the original thing. So as I already told you, all these things are already available in the f of x, or it is available in the MATLAB examples, okay, in demos. Then some of the other aspect ratios for the axis that also we will be seeing. See, axis equal, sets equal scale on both the axes. Square sets a default rectangular frame of a square. Then axis normal, it sets a default value. Then axis if you give, it freezes the current axis limit, and axis off removes the surrounding frame of the tick mark. Okay, so these are, it will remove the axis itself because axis is having a boundary. So these are some of the axis commands. Then next is multiple plots. This is what somebody was asking me, how to draw multiple plots. There are 3 different methods of drawing multiple plots in MATLAB. One is using plot command itself, you can do. Using hold command, you can do. Like in plot command itself, you continuously give x1, y1, x2, y2, x2, x3, y3. Then it will plot the multiple plots in that itself. So that is one way to write the plot command. Hold is you write a plot x, y, hold on, then give plot x1, y1. Then what it does, it then hold off. Then automatically both will come in that. Then using line command, using a line command also you can draw multiple things. So that we will see step by step now. So first of all, to draw plot command. So plot, see here I've already told you this is the plot command. So plot x1, y1, plot x2, y2, plot x3, y3. So you define all x1, y1, x2, y2 and you just give this command. Automatically 3 different graphs will come in that. So first of all, we will see that example. So this is a very small example where x1, y1, x2, y2, x3, y3 are defined. Then plot I am giving x1, y1, x2, y2, x3, y3. Okay, so again I'm explaining. See x1, this is your y1. Similarly x2, y2, x3, y3. Then plot x1, y1, x2, y2, x3, y3. Multiple title I'm giving as multiple plot, X label and this. So this program, let us try now. Okay, so this is x1, y1, x2, y2, x3, y3. So what you can do is this whole thing, you can put it in a M file and save it in some name. And if you call multiple, say I'm saving it as multiple plots. And if I call, automatically this will plot. So this whole thing, when it is a whole program, you can save it as in a M file also. So now the multiple plots would have come here. So you can see here the multiple plots x1, y1, x2, y2. And if I give a label also, it will give me the label for all the 3. So those things you can do it by yourself step by step. So next is using hold command, how to do it. So hold on and hold off are the commands for using this. So let us see the thing. So again, it is the same thing. You are writing x, y, you are just defining. Okay, x and y you're defining. X1, x is a common thing I'm using. I am just defining y1, plot x, y1. I'm holding it, hold on. Y2 I'm giving x exponential 2, that is my y2. Then plot x, y2, hold off. So what will happen, this is holded and then this is plotted, and when hold off, then both will come together and grid on. So this is a simple using hold command, how to draw multiple graphs. Okay, so this is to multiple plots, how to do using hold on command, hold on and hold off. Then next is same thing using line command also you can do. So line x data and y data if you give, you can, there hold on, hold off is not required. So x is defined, y is defined, then x2, say x is defined and 3 graphs you're going to draw. 1 is using plot command and 2 using line command. So here y2 and y3 is given. So they are drawing some lines here. So in this case, again, I'm just taking here. In this case, you need not single plot only is given, but you need not use hold when you use line command. Okay, so here in this case also, you can see here all these things, multiple plots are there without using hold on and hold off. So there are different, not only this, there are different other methods. That's why I'm saying MATLAB is like an ocean. You can do a lot of things using this. So for that, what is necessary is how to learn, from where to learn. So that I have given you an example where to, like, I have given you an idea how to go to help and search for things and do it. Everything, not only this. So when I learned, I didn't learn from any of the courses or I didn't go anywhere. I just learned it from this examples only. I learned fuzzy logic, I learned neural, I learned GA, PSO, everything just by going to the help of MATLAB and MATLAB file exchange. MATLAB file exchange also I'll show you. So before that, next we'll see the style. So now everything was drawing only, we were just drawing straight lines or all blue color or some same color. Now we want to change the color, or you want to change the dotted lines or star or anything like that. For that, you have commands in MATLAB. For color, you can give different colors like red, green, yellow, blue, or line styles you want to give solid, dash, dotted, or point marks you want to give like star, like zeros or plus. These things, what you can do is plot x comma y, and third will be the color. So if you want to give the color, you have to put it within single quotes. Say, and if you give the color and dotted like this, it gives you dotted lines in yellow, and this will give you dashed lines in green. So all these things are the different ways. Here a colon should come, and then if you give a star, the line will be in star, like it will be marked, and here a red color, zeros will come. So these are the different ways how you can make the style options. There are different other styles. Say for the color style, you can see here for yellow you will be giving Y, M for magenta, cyan blue you want C, R blue, B, G green. So these are things. And for point styles and the markers are also given here, solid, dotted, dashed, or all these markers are also available. And in case if you find, say, what I feel is when you want to draw a graph or something, if you have the data, you just call the data and you just plot, like call the data and go there. And I told you an option. When you plot it, you can go and edit the figure there. So there it is graphical. You can just go and put the dotted line. You can change the color instead of writing commands. So that is very simple compared to writing commands here. So here, this is a very simple example of with colors, it will be plotting. So let us see that. Here, T I have defined, Y1 and Y2 also I have defined. Okay, and plot. In plot T comma Y1, it is red color. T comma Y2, it is magenta with zeros. Magenta will be drawn, it's not a straight line, it is zeros. And X label I have given, Y label, title and grid on. So let us go and see the graph. So you can see the graph, red color, and the magenta is 0, 0, it is plotted. So when you want to give a some style to the graph, that you can use these commands. The next is legend. You want to write a legend there at the top, then you can use this legend command. So legend is within single quotes, you can give the string. So when you, or you can see the line style. Say you want to write a legend, the line style is that magenta with 0, 0 we gave. That is magenta with that 0, 0 is your voltage. If you want to give like that, the line style here you'll be giving magenta 0, the string name, that is voltage. Then you will give the line style. Again, the line style for the second string within, you have to write for the second string. That may be red with dot. If you give, the second will be, this is for legend, writing at the top. I'll just show you what is a legend with an example, you will understand. So legend position also. Say you have a graph. Legend is what you write it here. So you want a circle magenta, so you'll write circle, like that circle magenta line will come here and will say it is a voltage. So at this position, whether you want it in the right corner, you want it in the center, you want it in the left corner, that you will be just giving it with the position. Okay, the actual best position, it will apne aap, oh, 0 give, if you give 0, it will choose it by itself. Upper right corner you want, you give 1. If you want in the left corner, 2, like this, you can give it. Or if you want to switch it off, legend off. So there is an example for this. So here, cos, sine, and 2. Okay, so let us see what's coming, then we will define it. Position is 2. Okay, so here, so this is the graph here. So one cos graph is drawn and one sine graph is drawn, and its position is 2 here on the right corner up. Okay, so this is how you will define it. See, cos, sine. So here in plot itself, you have given x comma cos, and you have given how should it look. Okay, the style minus, since dot R. Okay, so here it is not only 0, it is a dash 0 dash 0. So that is here also dash dot dash dot. So that is what is given here. Okay, this dash is that, and a red the O. The sense it will draw in red, but it is not only 0, it is there is a dash also. The line will come and the dash will come, dash and a dot. So this is how you will draw the legends. Then subplot. So in this plot itself, I want to have different plots. I want one plot here with different axes. I want a plot here with different axes. I want a plot here with different axes. So for that, you draw what is called the subplot. Okay. So subplot command is subplot 2 comma break कितने बजे? 11 था. Okay. चाय वाला भी आ गया होगा है ना. So I think after the break, I think I continued for a long while. We'll just break for we'll break for कितने minutes? 10-15 minutes.
20 minutes.
Next भी मेरा ही है. At 40 we will call, is it? 11:40 we will reassemble. We will continue with the subplot, and then I'll do Simulink and then Arduino hardware. Okay. So here also the tea has come. So we will just break for some 15 minutes, I think. 15 minutes is more than enough. Okay, because I have to do Simulink and Arduino, so I want little more time. So we will sharp, now the time is 11:20. We will sharp reassemble at 11:35. So 15 minutes break you will have. Now the time is 11:20. We will sharp come back at 11:35. And we will start with the subplot. And at the end, when we come, if you have any doubts, you can ask me then, okay? I think many of the centers, they have some doubts also. We will clear it at that time. आप लोग भी चाय पी के आ जाओ. मैं तो ऐसे कंटिन्यूटी चल रहा था. अभी शुरू हो गया. So we'll go to the next session. So now we will continue with the subplot. Once the subplot is over, then we'll go to Simulink and then Adreno. Okay. So first of all, in subplot, as I already told you, in the same plot, when you want multiple graphs to be drawn or multiple plots to be done on the same window, then what we have to do is subplot is used. Subplot 2, 1, 1. In the sense 2 into 1. So there will be a plot there, 2 into 1. There is two. It will be only two plot. 2 into 1 in the sense there will be only two plots. Okay, in that the first plot. Huh? मैं ऐसे कर लेती हूँ because actually मुझे इसमें MATLAB दोनों में cross करना है. So here if you see subplot 2, 1 in the sense you will have a plot in this plot. You will have two plots, like say in the figure window there will be two plots. So if one is 2, 1, the first element, that is 2, 1, 1 means the first. In the first one it will plot, then 2, 1, 2 in the sense it will plot in the second one. So it is something like this. If it is 2, 2, 1, in the sense 2 into 2, 4. So there will be 4 plots. If you write subplot 2, 2, in the sense there will be 2 rows and 2 columns. In this case, 2 columns and only 1 row. Okay, so that is how it is done. So we'll see an example, then you will understand clear. So now in this example, we have to draw 4 plots. Okay, so it is 2 into 2, like that, so that 4 plots can be drawn. One is voltage versus current. So here you can see V versus I. So where V is given 4 into I and I value is 1, 2, 3, 4 on it is given. Then plot Y versus X, where Y is X squared. Then you have a plot like T is equal to 0 to pi in step T. T is pi by 60 and plot sine T is given. And next is T is equal to 0 to pi in the steps of pi by 30. That is 2 into pi, 0 to 2 into pi in steps of pi by 30. So now again we have to plot. So these 4 plots are there. These 4 plots we have to do in 4 separate graphs. So in order to do that, so the commands are this. I'll just explain the commands. Here you can see I is defined. In this case, you can see for the first plot, I is defined, V is defined, and I am just making a subplot. Subplot is 2, 2, 1. In the sense 2, 2, in the sense there are 4 plots. 4 plots are made. So in this 4 plots, the first plot, that voltage into current will come. So there are 4 plots like this. This the first 2, 2, 1 is the first one. This plot I, V, title and X label, Y label you will do. Next again X and Y plot 2, 2, 2. In the sense this one 2, 2, 2. Then again 2, 2, 3. This one will be plotted. This is the subplot this. And again you will give the plot command T, sine T, plot this. And then last is subplot 2, 2, 4. In the sense this is this one. So for that plot T, cos of T. So this one we will just now execute and see. So first of all, I'm just doing only 2 plots. So you can see here, only 2 plots are coming here. 2, 2, 1. So only 2 plots have come. And next, the remaining program also I am just putting. So automatically you can see here 4 plots. So you can see the voltage and current, parabolic plot, plot of sine function, plot of cos function. So you can see the position accordingly. You can have, say here, voltage and current was the first, then was the parabolic plot. So parabolic plot was this one. So this is correct. This one voltage, then parabolic plot, then plot of sine, that is 3, and this is your 4. So when you want to do 4 plots, you can do it like this. So this is for subplots. When you want to have subplots, you go for this. Then there are different other plots also, 2-dimensional and 3-dimensional plots. Some of the plots are the bar plots, the stair step plots. So all these things I already told you. You can go to the example and you can do it. So here, just let me just help you out in pasting this. So x value is given minus 2.9 to 2.9 in steps of 0.2. Now you have to draw the bar. So you can see here, bar is the command with x comma the variable. So here, in this case, x comma, this one you can put it in y also. Y is equal to exponential of this, and x comma y also you can give. So in that case, you can see the bar graph here. Okay, so here once you close this graph figure, this is x and this is your bar. So this your bar graph is here. Okay, the x value is defined and your bar is given. So automatically you can x is given and bar is given and you will get the value of bar. This is your bar graph. Similarly, next we will see the stair step plot. There is a staircase. In that case, again the x value is defined. Okay, x is defined. X is x to 10 steps of 0.25 stair of x comma sine of x. So x comma y also you can put where y is equal to sine of x. That is also possible. You can do it like that. So here in this case, you get a step like this, sampled signals. In order to sample it, you can do it like this. Then you have error bar plot. So error bar plot, let us just plot and see. This is mostly used in statistics where ERF, that is error of the function. What it does is, it just takes the Gaussian function, it will just find the error with it and corresponding error and it will plot it. So here you can see the x value, y value and the error, random error and the error bar. Error bar is the plot that is used for plotting the error in statistical analysis. So here this is the error plot. You can see here, this is the error plot. So after that, polar plot. For t is defined, then polar of the whole variable x comma y you have to give. Okay, so here you can see t is given, polar of x comma the y the variable as such, instead of y they have given absolute of sine 2 into t dot star cos of 2 into t. So this is how it is given. So if you can see the polar graph here, so this is the polar graph. So you're based on your application, you can go for different plots. One is the stem plot. So again in sampling, mostly the stem plot is used. X and y is there, stem of x comma y. In Fourier analysis also, mostly you can see this. So this is your stem plot. Okay, and the last one I'm just taking the color map. So color map, maxima minima, this will be a very helpful in GAPS and all. You can plot this and see this plot. So this plot gives you where is the maxima existing, where is the minima. So in GA, whether you have achieved the maxima or minima, all these things you can understand it from this plot. So this is the mesh plot of peak. So Z is equal to peak of 25, mesh of Z and color map HEV. So this I already told you, you need not worry. In order to learn these things, go to help, go to 2D, 3D graphs or anything. You can go to any location where which one you want to learn. You can go and learn. Say if you want to learn fuzzy logic, go to the fuzzy logic help here. In help you have fuzzy logic. Go to fuzzy logic and there fuzzy logic toolbox examples are given. You just go and open the script here. Okay, the script file is here. The script file you just open this example. So this example fully, this is some kinematics example, modeling inverse kinematics in robotic arm. So the example is given here fully. So what you can do is open this example. If you give, the code will be opened. For all the examples, the code, see this is the code opened here. It's an M file, the whole code is available here. Okay, the whole full code is available. Now what you have to do, go to the editor, just run this program. inverse kinematics underscore this. So this you have to just run it. So it is inverse code starting training first ANSYS network. So it is some ANSYS adaptive neurofuzzy inference system network it is taking and it is operating it. Okay. So it is, I think I did a big mistake taking a big program. It's starting the training and the program is going on. Okay. Anyway, it is running fast. Starting it is an ANSYS adaptive neurofuzzy model has been taken and it is training the network. Okay, so you can just take any program which is already existing. So when you see the program, sometimes it seems that you can't open it. What you have to do there is you have to go and open that model. Once you open the model, you will get the code. Once the code is there, automatically you can start running it. So now it is almost over and you can see all the K1, K2 values and all these things here. Okay, and the graphs are also have come here. Okay, anyway, I don't know the program, what is it? I simply opened a program and I just showed you. But there, what you can do is, you can just go and read what they actually have done it here itself. What is inverse kinematics? What is ANFIS? Say they have given all the things here. And data generation, how they have generated the data of the arm. And step by step, you can just run this portion. You will get the graph this. So step by step, you can fully do it and see. Okay. So and here all the graphs would have generated fast and we got this graph at the end. Okay, so you this model, if you want to have an animation also, that is also possible. You have to for the animation you have to go to this link and you have to operate it. So here many such examples are already existing. You have to just open, say this is gas mileage prediction. So this gas mileage prediction, also open this program and run it. Sometimes it will take more time. So I don't want to waste my time here. So that's why I'm not going into it. But you can just go into any examples what you want. You want some embedded coders, DSP systems, or for curve fitting toolboxes, data acquisition toolbox, or robotic controls, or you have your SimScape, coders. So in SimScape itself, under SimScape, you have your you have Sim electronics, Sim power systems. You have many other things coming under SimScape itself. So next is, now we have seen a lot of coding. Okay, now I will go into some graphical application, that is nothing but your Simulink environment. So in Simulink environment, there I'll just show you. This is the Simulink library. I think all of you can see the Simulink library here. So this is the Simulink library. You have to just click on this Simulink library. And in Simulink library, almost all the toolboxes are already there with all the functions and all the block sets. Okay, so here whenever you want some blocks, you have to just drag from there and put it into your system and reconnect it. So I'll be just showing you step by step. But learning the Simulink, there are some basics. You have to know some few things so that Simulink will be very clear. One of the thing is nothing but your making a subsystem. Say you have a very big system. You have a motor control system. In that, first you have to make a motor. Okay, then you will make a controller. Then you will have a controller is nothing but it will be at a very low voltage level. It will just give you control signals. You have a power circuit. In the sense, you will have some thyristors or some relays to turn on or turn off the motor. To control it also, you have some power devices there. So all these things, when you simulate, what will happen? It will be a very big mess there. Motor, when you want to simulate, it should have a field winding, it should have an armature winding, it will have number of brushes, this. All together, once you simulate, that itself will come to 2 pages. Then controller, it may be any type of controller inside PID controller, or it may be a microcontroller based controllers. So all those embedded programs, it will take the voltage and current, it will compare, do a lot of things. So all these things, once you put it in a single sheet, you itself will become confused, what is what. So what we do, we make subsystems. Make a motor, select all those things and put it inside a block and we say that is a motor. Then power supply and all the accessories, we put it inside and we say that is the power circuit. Then we put all the control circuit inside one Okay, and that PID controller, or it may be a current controller or anything, we put it inside. It may be eddy current based controller or fractional controller, anything. Put it inside a block and say that is a controller. Now connect these three. You will understand. If you want to change something inside the motor, go click on that and you go and change it. So you know what is where. Okay, so that's why we have to make a subsystem first. Next is masking a subsystem. You have some concept. So now anyway our window is open, it takes little time. So here this is the Simulink library. All things commonly used block, if you see, say you have a constant, you want some data type converters, you want a gain, you want this, all these blocks are already existing. So what you do, you just a new model block, when you want to open a new model, a small icon, this is the icon which you have to remember. Okay, so this icon, if you click, automatically a window will open. In that window we will just drag all these things and go and put it there, and we will reconnect it. Okay, so this is the window. So what say now, for example, simple thing I'll show you. I'm just putting a constant. I am putting two constants. Okay, and I want to add it. Some logical operators is wider. I want to do addition or subtraction like that. Say I'm just putting this multiplication. Okay, so here let me give, just double click on it. I'm giving some variable 3. Apply. Okay, so now I want to find the sum. So here element wise multiplication. This is for multiplication. If you want addition, you can just go and take addition blocks. So all these blocks are available here. This is commonly used. Those blocks will be available in math operation. Okay, in math operation, if you go, you will get all the mathematics, say dot product, all these mathematical function. Addition is this for adding two numbers. If you just double click and make it minus, you can add one and you can subtract. So these are the things. So now you can just multiply these two and you want to display it. So display all those things which you want to display will go into the sink. You have something called source, and similarly you have something called sink. So when you want to see the display, you can just take a display, connect this, and just for running the program, you have to just click on this run. So automatically it will run and give you the answer here. So 1 into 3, it has to give me an answer 3. So it is displaying the answer 3. Okay, so here you can see this is a simple thing I showed you. Okay, so here one thing what you see, when I double click on this, a window will open. Okay, and it is asking me what is the constant value. Okay, so similarly let me take some other block. I just want to show you a concept called masking. Okay, so masking, why do we go for masking? Say I told you here itself, when we clicked on this constant, a window opened and it was asking me what is the value you want to enter. Okay, similarly in this also masking, say for example, if I want a motor, I can just click on this and here type it also. I can click on this window. I can click on this window. Okay, this is paused, that's why, sorry. Okay, so here, let me say I want a thyristor. When I put a thyristor, automatically here in the new versions, this is after 13, I think, 13 or 14, you have this option where you can just go and click on the screen itself and write it there, like write half of the name, it will give you the option what is available, THY. So if a thyristor will come. So let me select a thyristor and click on it. So automatically your thyristor will come there. So after that, once the thyristor block is here, if I double click on this, a window will open. If I double click on this, a window is opening and it is asking me what is the value of resistor you want to keep. What is the inductance you want? What is it for? So this is nothing but a masked window. Okay, this is masked. This variable resistance is masked there. I have not given any value inside. I have just given a variable A. So that A variable I am just defining that resistance, or say RON was the variable which was defined inside. So now I can give that variable as 0.001. So that is nothing but called the mask. You're masking a variable and you are entering the value. So now we are just going to see some important concepts like what is a subsystem and what is masking, how to do masking. Okay, this is already masked, inbuilt, already existing element I have taken. Okay, now we have to see how to do all these things, how to make a subsystem, how to mask a subsystem. So for that, let me first of all, before going into it, I am just going to take a small example and do all the concepts which are available in Simulink with a simple example. Okay, for understanding purpose, the example what I am taking is a simple example which all the field people can understand. You're from electronics, electrical, mechanical, or even from in 12th standard itself, you would have learned a concept of rectifiers. Have you all learned rectifier? Rectifier is that which converts AC to DC. Okay, so now we are just taking an example of a rectifier. I'll just explain the rectifier because many of you, if you don't know also, you will understand what is a rectifier. And then we will go into the concept of what is masking. So for a rectifier, say I have some diodes. I am taking 4 diodes. It's a bridge rectifier. So I am taking 4 diodes. Okay, I am giving a supply for this. That is an AC supply. So you are using this every day. This circuit you are using every day. This is, say, in your mobile. Your mobile charger, you go and connect it in your house to 230 volts. So that 230 volts is this. Okay, this is the 230 volts. But your mobile, once the output of the mobile is say 5 volts or something for the battery of your mobile. So you just think this is the input supply, it is getting rectified, and this is your load here. Your load is nothing but your battery of your mobile. Okay, so it is a mobile charger. Just think this is a mobile charger in between. Your load is the battery. So here you have on DC. This is 230 volts AC supply. This is your AC, and here you get some DC voltage. So this is the simple circuit. So now what you are going to do, as I already told you, you have given AC supply. So in India, the supply is 50 hertz. Okay, 230 volts, 50 hertz. So this is the supply. And once, say, during the positive half cycle, here when the positive half cycle comes, this diode, say, let me keep it as 1, and this is your 2. And let me keep this is 3, and this is my 4. So what happens, this 1 and 2 are forward biased. This is your anode, this is cathode, this is your anode, cathode. So during positive half cycle, these two are forward biased. So this supply will come to the output here. Same output will come here. So you will get a output this. Okay, this has output. Next half cycle, during the negative half cycle. During the negative half cycle, when here it is negative, what will happen? This 3 and 4 are forward bias. During that time, these two are reverse bias because negative supply is coming. This is your anode, this is your anode. So these two are reverse bias and these two are forward bias. So what will happen? Across the load, this is forward bias and this is forward bias. Across the load, again you get a output like this. This one gets shifted up. So this is said to be full wave rectifier. You get DC output. AC has become DC. So this is what is happening in your mobile rectifiers, like in your mobile chargers. You get DC. So this is said to be pulsating DC. It is not a constant DC. Okay, then using a filter, a capacitor or something, you can make this constant. So this is what we are going to do here. So here, during first half cycle, during this cycle, what was happening? 1 and 2 was forward bias, 1 and 2. Okay, so that firing power that has become for 1 and 2 was forward bias. That's why you got this. And during this cycle, 3 and 4 was on. Now what I'm doing In these diodes I am making as rectifier. Sorry, these diodes I am making as thyristors. This is just to show you the concept of masking. Okay, you will understand why I am making it as thyristor. So thyristor is that which you can control at any instant. Here in a diode, what will happen when this becomes positive? When this becomes positive, automatically diode will get turned on. But thyristor, even if it becomes on, it will not get turned on until you don't give a firing to this. So these two are forward bias, but it will not get turned on. So let me take that after some 45 degrees, that is 45 is this point, I am turning on this T1 and T2. Here at this point I will be turning on. In the sense I am giving here a firing pulse at 45 degrees, that is for 1 and 2 to turn on. So how will be my output? After 45 only I will get my output. Similarly 3 and 4 I am just firing after 45 degrees. So here to here again I will fire. So my output is controlled. It is not giving me the full output. So this application where you will be using in our fans. Say fan regulator is there. That is nothing but a thyristor. So what you do, you just don't, when you want to reduce the speed of the motor. Here when you want to reduce the speed, full voltage will not come. Only a reduced voltage will come. So automatically when you get a reduced voltage, fan speed also will get reduced. So that is an application. So here, say here I am giving firing pulse at 1 and 3. Again next positive cycle I will be giving it here. Similarly, another thyristor, this is for thyristor 1 and 2. For thyristors 3 and 4 I will be giving a firing pulse here and I will be repeating the firing pulse here. So again I am telling, don't get confused like why ma'am is teaching all these things. I am just teaching you to tell you some concept about what is subsystem and what is masking. So here if you understand this, I can easily explain. I will be doing the circuit and I will make a subsystem and show. Same thing in your circuit also you can do it. Okay, so here I am just turning on these two thyristors at this firing pulse and I am repeating the firing pulse at every positive cycle. This is a positive cycle, I will be giving a firing pulse. So again 1 and 2 will get turned on here. Okay, so here now I have to tell my computer at what time. This 45 degrees computer will not understand. I have to tell my computer at what time. In terms of time I have to tell. So what is this time and what is this time? And what is the time at which this should repeat, that I have to know. So we know that 50 hertz, this supply is 50 hertz. 50 is your 50 hertz is your supply. Okay, so what is time? Frequency is nothing but 1 by T. Okay, 1 by T is nothing but your frequency. Frequency is nothing but 1 by T. So your time for frequency is 50 hertz and your time is 20 milliseconds. 1 by 50, that is 20 milliseconds is this whole cycle. So this whole cycle is 20 milliseconds. Okay, this whole cycle is 20 millisecond. So this whole cycle is 20 millisecond. Then half the cycle is 10 millisecond. Then this 3/4, like 90 degrees is nothing but 5 milliseconds. So 45 degrees, if I say it is 2.5 milliseconds. So when should I fire this? I add 2.5 milliseconds. And what is the firing angle? This one for 3 and 4. This is 10 milliseconds. So this is 2.5 milliseconds. So here I have to give 12.5 milliseconds. So here I have to give 12.5 milliseconds. 3 and 4 I have to fire and I have to repeat it at 20 milliseconds. Every 20 milliseconds, because here if I fire again negative, the same point I have to fire again. So every 20 milliseconds you will repeat it and your first delay will be 12.5 milliseconds and here it is 2.5 milliseconds. So computer will understand only in terms of time. So whatever thing, even if you are controlling a lathe or you are controlling an aerospace application, you have to give it in terms of time. You have to say fire this motor or something. So for actuator is required to turn the space shuttle. Okay, at one particular time you have to fire. So what is the time? How will you give? In terms of time. You have to convert everything in terms of time. So the system will have a clock there. Say the clock, you are using a microcontroller or something. It has a clock frequency of 16 megahertz. So accordingly, you have to according to the clock time, you have to calculate at what time you have to fire a particular thing. So that here, in this case, if it is 50, say supply which is coming is 50 hertz, we know that it is one cycle is like 50 hertz in the sense the AC makes 50 cycles per second. 50 hertz in the sense it makes 50 cycle per second. In 1 second, it is oscillating 50 times. Okay, so this time you are just, so if, one cycle is 20 milliseconds. In every 20 milliseconds, it is making one cycle. That is how, for any problem, you have to calculate it properly. Calculation is very important. So this is okay. Now the same problem, we are going to do it in MATLAB. So for that, I require a thyristor. So I am just taking a thyristor. I showed you thyristor. So I am just taking the same problem only. I am just doing it little fast because we are going out of time. I am just copying this. You have to just Control C, Control V. If you do, you can copy this. And now this is over. I require a AC voltage supply, AC voltage source. So I'm just taking a AC voltage source. You have to just type what you require there. Okay, once you start using this, you will become a little more familiar. I'm just connecting all these things. This is just to show you the concept of subsystem and masking. I'm doing this. Okay, so AC supply is here. I'm just connecting my AC supply. So here I have to come and give the value. So AC, I told it is 230 volts. So 230 volts and frequency is 50 hertz. So 50 hertz. Apply. Okay. Okay, so the other things, values are already there. I require a load. So let me take an RLC load. RLC series branch I want. Okay, so this one, Control R, I'm just rotating it. I want a current meter. That is nothing but an ammeter. So measuring the current. I require a voltmeter, voltage measurement. Okay, I'm just copying that here also. You have to just drag and put the elements and connect it like this. With the wires, you have to connect it. It is very simple. So I've connected the voltmeter. Now all the voltmeter ammeters are there. I want a scope to look into. Scope is like a CRO. Okay, just I want a scope, but how many elements I want to see? I want to see 1, 2, 3. Apart from this, I want to see the pulse generator also. To generate the pulse. So this is the pulse generator. I require 2 pulse generator for 2 thyristors. So we said P1 and 2 require the pulse. This is what I said. When I made so many, I am itself confused where are the things. Is it? So that's why we make a subsystem. So this is a rectifier. This is your source. This is the source voltage will come here. Okay. Source voltage, you will get it here. This is the pulse generator for this. And this is your thing. So scope, how many I want to see? Let me see some 5 parameters in the CRO I want to see, or a scope I want to see. So you have to go to, in scope, when you double click, a window will open, and here you have a option for parameter, which I have clicked. So that one I have to just click, and number of axes I am just converting into 5 axes. Apply. Okay. So automatically you can see 5 axes have come here. So what all things I want to see, I can see it in this scope. So let me see this voltage. Let me see the source voltage, the load voltage, current. Then let me see the pulse generator. So all these things I want to just note it. So which all things I want to note, I have just, all the things which I want to note, I have just drawn it here. Okay, so all these things are here. So now what we require, we just want to, I just want to tell you the concept of how to make a subsystem, and next is how to mask a subsystem. So for that, so here, what is a subsystem? How to make a subsystem? You have a source, you have a load, and you have the CRO to look into the output. So I just want this item. This is my rectifier. So I just want to club all those things, put it inside a single window and say that is my rectifier. So in order to do that, I have to select only those elements. So in that elements, you can see a measuring port here. So if that port is not required, you can use terminators and terminate it. Otherwise, all those ports also will come. Or what you can do, you can just double click and show measurement port. You can just remove it. So that port will go. Otherwise, when you make a subsystem, these ports also will come there and it will confuse you. How many ports will be there. So you can just, I'm just removing it, or whenever you have some extra terminals like that, you can just terminate it. So I've terminated it. I just want to put all these elements into one and make it as a subsystem. So let me connect these things. Okay, only these things I have connected. This is the rectifier. I am just clicking right. What I have to do, whichever elements you want to put it in a subsystem, connect that. Okay, so that one I have connected. And keep it over any element, right click on that. Okay, when you right click, automatically a window will open like this, and here there is an option for create subsystem for selection. So what you will do, you right click on it and create subsystem for selection. That option you just click. So automatically what happened, this is a subsystem. So you have a subsystem here. So this is your input. You have your input here coming from the AC voltage, and you have two things. One is this is your load. Your load is connected here. This current meter is going, and this is the other end of the load. And what are these things? These out 1 and out 2, you are seeing this is the pulse generator output. I had a pulse generator inside, is it? So this is the pulse generator 1 and 2, the pulse generator output. What I can do is I can remove this here. I can remove these two, and you can go inside and see. So these connections also got cut because these are little confusing. So I have removed it. So how to bring the signal out? So what I can do, I can use to go to blocks. So put go to tag. So go to blocks. So you can have two go to blocks and just connect it to this. Okay, so this one you have to name differently. So let me name it as B. And one more thing you have to remember is, when you are taking this from one subsystem to another subsystem, inside you have to mention local as global. It should be declared as global. Otherwise, outside it will not be seen. Okay, so here you have put go to blocks. Now you can see here, I will go and add the from block here. So go to A and B, two variables I have defined, that will come here. So from block, put from, just click on this, you will have two blocks. Okay, you will have two blocks. Just click on this and connect it here. Here and here, these are the go to blocks. So when you click on this, say A, okay, now update the tag. Okay, so it is not showing anything. A, you clicked OK. Similarly, B also, you can just name the variable B, apply it. When you apply, nothing is coming. It's not showing the tag. The reason is, say, I'll just run and show you. This will not run. It will show me an error because all these elements, it require one more block called the power GUI. I'll tell you about the power GUI later. So now let me run this. So when you run this, you can see there. See these two blocks, there are no outputs coming. So now, what is the reason these two outputs are not coming? Because it's not getting a link from inside. So for that, what we have to do is, we have to go inside this go to tag, click on this, and this is a local. Once it is local, it can be seen only inside the subsystem. So make it as global. and apply. Refresh. Okay. So now you just click on this link. See, you will get a link here and it will show you where it is going. It is going outside the block and it's coming here. Similarly for the B also, you have to go inside, go to this and make this as global. Until you don't declare it as global, it will not be seen out. So here you can see it is B. So these two variables are coming out. So now little settings are required. Those things I'll do. I didn't do any setting. First for the pulse generator, you have to do the setting, is it? What was the period at which the pulse have to repeat every time? 20 milliseconds, is it? I told you every 20 milliseconds it has to repeat. And what was the delay? 45 degrees in the sense it was 2.5 milliseconds. So 0.0025 was the milliseconds you have to give here. I told you every calculation you have to do it in terms of time and give it, then only it will understand. Similarly here also you have to define for the other 3 and 4 thyristors. So 20 milliseconds is your period and your phase angle is nothing but again it is 12.5 milliseconds. I showed you that in the thing. So for 12.5 is 0.0125. 1, 2, 3, 5. Yeah, it is 12.5 milliseconds. Similarly, after this, we have to have the settings for this also, load. So for example, say I am in different types of load. If I want an RL load, I'll be selecting that and you can set the values, how much you want. So 40 ohms and I'll just keep some 80 millihenry of inductance, apply, okay. And I'll just reduce the time period for which I want to see the graph. Otherwise, it will be confusing. You can't see all the graph clearly. So I think all of you can see the full diagram. And so now what we did, we changed the load, we set all the values of pulse generator and everything. Okay, so now we will just run this program and we'll just see the output. So not to see the output, just click on this and this is the auto scaling. Here you can see a symbol. So this is auto scale. Click on that. Automatically you can see here. So if it is not clear, you can just go and do the parameter setting. You can start as we did in MATLAB, same way you can change the scale, color and everything. So I'm just changing it so that it will be little more clear. Thickness, all these things options are available here. Okay. So you can see the graph here. So this was the So you can see the graph here. So this AC supply was a supply, this AC voltage. Then this was a load voltage, which you saw here, this voltmeter. Then you have a discontinuous current going here. That is this one when the inductance value, they say here the negative current is going and sorry, negative power is there in the sense the voltage is going negative in the sense the energy what the inductor has stored is giving back and it is becoming zero. That's why the current is becoming zero. And the pulse, I already told you, this is the pulse for T1 and T2. Okay, T1 and T2, the thyristor which I showed you, that is these two thyristors, like these two thyristors, the firing pulses, it starts at 0.25 milliseconds, then every 20 milliseconds it repeats. So this problem what I explained, same thing we have done it here. Okay, so here our main aim was to show you how to make a subsystem. So in case if I want to put these two into a subsystem as a source, I can just select this, right click and create subsystem. So this will also become a subsystem. I can give here the name supply. Okay, so this is a subsystem. Now next, let me tell you a concept called masking. What is masking? Say when I click on this, a window is asking and it is masked and it is asking me the value for resistor and inductor. In this case, when I click on it, circuit should not open. It should open a window and it should ask me what is the firing angle. Okay, because firing angle is that which I can change. Is it here? I kept it as 45. I can make it as 90. I can make it as 180, anything. So that is why I just put it as a thyristor there, just to show you the concept of masking. So for that masking, what we want to do, here also you can mask. You can just go and put this variable 230 as A. If I put a variable, then it will ask me what is A. Okay, so here in this case, I will show you the block which subsystem what I made. Just double click on it, go to the pulse generator, and let me keep this variable phase angle as A. Okay, and similarly, let me keep this as B. So two unknown variables, I am just keeping it. If you run, it will give me an error. It will tell me, I don't know what is a variable of A and B. If I run this program, it will give me an error. Because inside this, I have kept two variables, A and B, which can be changed every time. So how will you create a mask? Just right click on this. Go to mask, create mask. You have an option called create mask. Again, I'll just show you, right click on it. Okay, and here you have an option called mask. So you have to go into this option mask. Okay, so right click, go to mask, create mask. A window will open. In this window, you have to set all the parameters. So in case if I want to see a picture here and I want to write some variables, say for example, I want a function to be written like this. I want a function 1 divided by z squared. I have made a block of a function. I want a function to be displayed. What I can do is, it is nothing but d poly, numerator and denominator term. I have to just give it here and just put apply. Automatically that function will come here. Or if you have made a rectifier and you want to put a picture of a rectifier there, or you have made a lathe or something and you want to put a lathe picture there, or you have made your own function, and for that you can put the images also. So image, the command is image with within brackets single quotes. You have to put the image, any JPG image. You can go and put it in the Simulink link there in C prompt. Okay, and in C prompt in program files, you have the MATLAB. Go inside MATLAB and you have Simulink. Simulink and toolbox will be there. Inside toolbox again Simulink and again Simulink. In that location, or what you can do, go and search for this B747.jpg. It will give you a location. In that location, go and put your own image. Whichever image you want, you can put. So if you put this image there, copy this and put it here. And just put apply, this image will come. Okay, so if one more image is there, I have just put it as a Simulink theme image is also there. So just update it, apply. So the Simulink theme image will come. So any image, whichever image you want to do, if you want to put an aeroplane image, or you want to have a space shuttle, or if it is a controller, you want to put, all those things are possible here. What all command, what we wrote in MATLAB, plot command, everything is working. You can make a plot here also. Anything, whatever plot you want to make, or whatever commands you have in MATLAB, that can operate here. Next, after this, what you have to go to this parameter and dialog. So this is a place where you have to define the parameters. Okay. So here you want the parameter to be edit box or your check box or anything you can put. So I am putting it as an edit box. So I want two edit boxes because I have two things. One is my firing angle 1. So what was the parameter I gave? The same parameter I have to give here. Let my parameter be A. And my firing angle 2 is nothing but the parameter B. So what parameter I have given inside, the same parameter should come here. Otherwise it will be a mistake. It will show you, it will tell me I don't know what parameter you're defining. Okay, if you want to initialize, say if it is an inductor or some other value, you can initialize those parameters also. What all parameters you defined here, if you want to give some initial value, you can give it here. Then documentation, because now you have made your own block. So you can write some documentation. Okay, you can define this is a rectifier. You can give a MATLAB link here. Anything you can do. So apply and OK. That's it. So now you go and click on this block. This window will open and it will ask me what is the firing angle you want to give. So in this case, if it is 90 degrees, 45 I said 2.5 milliseconds. 90 is, it is around 5 milliseconds. So I can give it as 0.005. And here in this case, it will be 0.05 milliseconds, in the sense you have to give for 10 plus 5, 15 milliseconds, because one half cycle is 10, then again 5. It is 15 milliseconds. So this is for 90 degrees firing. So let me run the program and see. So here you can see now the same problem is for 90 degrees. You can see here it became more discontinuous, and here this portion also has reduced around 90 degrees. This is the 90 degree. So this is 90 degrees. So every 90 degrees the firing is taking place. Okay. So that is what is shown here. So next is, if I want to add some program which I've already written in C, or I have a .m file, already I have a GA program, I have a PSO program, I want to come and embed it here. How will I do it? So for that you can go to the library window. In that library, you have user-defined functions. So these are some of the user-defined functions. So here you can see when you want C programs to be, so S function can be used, Fortran or C program, you can use this S function. Or if you have an M file, you can use this MATLAB function. So just now I'll just write an M file and show you how to use this function. So let me use this MATLAB function here. So when I put this MATLAB function, this function will come here, and now you have to just how many inputs and how many outputs you want, you have to define. So just double click on this. So this M file will open. So this is the M file which we already learned before, same M file. So what we did, we actually put that function and we double clicked on it. When you double clicked on it, a function will excuse me. So when you double clicked on it, this function will open. Now you can come and write the code here. So how many outputs I want? So let me keep that. I want 2 outputs. So I'm writing y1 and y2 are my 2 outputs. You have to put it within brackets, square brackets. And how many inputs you want to give? Any number of inputs. Y1, you want to give say 5 inputs, you can just give it here. So x1, and let me give 2 inputs. So function is u1, u2. Okay, 2 inputs are there, 2 outputs are there. Then I have to define the function. So my output y1 is equal to u1 into some 100. Let me keep it that I am defining my output y1 as input 1 into 100, and my y2, let it be equal to u2 itself. Okay, simple. I'm just, you can write your GA program here, PSO, anything. So for GA, what are your inputs that you have to define here? For what are your outputs you will be defining here. Or if you are using a Newton-Raphson program, your Newton-Raphson inputs will be here, outputs will be here, and your full program will be here. Okay, and this one is default there. It is just for code generation. Like any error is there, it will generate. This is the syntax. You need not change it. This already existing, only your program, you will go and paste it here. So now you can go to the Simulink window. So you can see here, when you run this program, automatically so when you run this program, when you run this model, which you have already done it, automatically, so it is running this model, 2 outputs will come and then we can select it. Okay. So now you saw that now 2 inputs and 2 outputs automatically came here. Now we have to give the inputs. So let one voltage be my one of the input and another current be my another input, and output is scope. Scope is my output. So let me have 2 variables there, axis. So you can see the output here. Okay, so I'm just running this program. So any code, when you have some code, you can have it here. So you can see the output here. Okay, we multiply the input with 100, so that is why the power has gone to 10 to the power 4. Here the output, like the voltage, current is as such taken as Y2. Okay, so if it is a closed loop system, what you can do, you can just go and connect it back to your problem itself. You have a control system, like you have something else, and you want to go and make it as a closed loop system, this output will go and get connected to the closed loop system. So any program which you want, codings which you want to write, you can write it here. So this is the advantage of Simulink. Graphically, you can do all calculations. Okay, Simulink is also a very easy way to do the programming. So these are the two methods, one is using MATLAB I showed you, with Simulink I showed. Now we will go into Arduino. So before that, do you have any doubt in this? Because Arduino also, it will take me at least 20 minutes, 20-25 minutes I require minimum to show basics. So I have time. Do you have any doubts in Simulink centers? Because same thing only in Arduino also we are going to have the same. I'll be using a graphical user interface, same commands and everything. So in this Simulink, till now, Simulink and coding, any problem? Okay, let me finish Arduino also, and at last I'll ask you so that you can give the comments, comment for that also. Okay, so first of all, as I already told you, Arduino is a controller. Okay, it's a microcontroller that can be interfaced with this with your MATLAB. Okay, so I'll just show you the Arduino. Sir, वो bag में एक box है छोटा सा. हाँ. Thank you. Sorry. So this is your Arduino here. So all of you can see, this is my Arduino. Okay, Arduino block. So this hardware, which you can see on the screen, is a very useful thing for doing projects. Okay, small. Any program which you have done in MATLAB can be easily implemented using this Arduino. This is the simplest version of Arduino Uno, you can say. Okay, so this is the, I think, same thing I'll be just showing you in your screen. So that you will be seeing all the input output ports and the controller, everything I'll be explaining it still clear. Okay, so you can see all the pins. You have here input pins. This side you have the digital input output ports. Here I have the analog input output ports. Okay, A0 to A5. This is the USB port. This is your power supply port. If you want to individually operate it, you can give power supply for this using this. And this is your Atmega 325 microcontroller. Okay, 328, I think, 328 microcontroller, that we will be seeing it in your PPT now. So I'll just show you the PPT. We'll just go into the PPT. There, clearly it will be seen. See my PPT here. PPT is seen here, and in this here we will be mainly seeing the Arduino with interface, MATLAB with Arduino interface. I'll be just showing you. So this Arduino is a very low cost device. It costs only 400 rupees. Okay, the thing original it will be around 1200, but now many makes are coming. For Arduino itself, you have Redrino, all these things operate with the same software. So this Arduino is a very cheap controller which can be interfaced with anything. Like you can interface with LabVIEW, you can interface with MATLAB or any other softwares also. Many softwares, this is interfaceable. And not only Arduino, you have Raspberry Pi, Legos, and you have number of other cheap controllers like this which you can connect it with MATLAB. So for that, some add-ons are required that I'll be telling you step by step. So this is MATLAB with Arduino interface. So before going into this, I just want to give you a small story, because till now fully listening to MATLAB and Simulink, I think all of them, all their brains are full with technical stuff. So let us now hear a small story. So have you seen this Rhino motors? Mechanical, any mechanical people, they would have known it. You know, have you heard of Rhino motors? Any idea seeing this figure? What is Rhino motor? So this Rhino motor is a bike. Okay, that bike which operates with a single wheel. Okay, it is a single wheel bike. So Lawrence, who's standing here, and Chris Hoffman. Chris Hoffman is the main CEO of this company. He is the one who is the founder, you can say. He's the founder of the company. And Lawrence is his daughter. And now we will just see a small story how this company started. So Lawrence, when she was around 6 years old, she is very fond of playing with video games. So she plays this video game. She plays with this video game, Dragon Ball. So once she was going with her father, Chris Hoffman, for a small fishing. So usually in foreign countries, they go and for fishing and all, and even India nowadays, we people also do all these extracurricular things. So once she was driving with her father, she was telling, Dad, you are a mechanical engineer. Why don't you make a bike for me like this, but like the one which comes in the Dragon Ball? So he has not seen that. He said, which Dragon Ball? What? Which bike? Then she drew this diagram. This is the original diagram drawn by that girl. That is daughter of Chris Hoffman, and which has a handle, a relaxing place for the legs, and a mudguard, and the overall structure is like this. Okay, so now once he told that, he went to the garage. He has a garage at home, mechanical engineer, so he had a small mechanical stuffs out there. So he went and made this prototype. So that's what I said, whenever some idea comes to your mind, before going and implementing as a bike, you have to make a small prototype and check, because this is a single wheel bike. Okay, the single wheel bike, what is the challenge there? When there is two wheels itself, we don't know how to balance, we fall. With a single wheel, a normal man cannot operate it. So what is required is self-balancing is required. The machine should self-balance there. So that was a very important thing. So for that, what he did is the motorbike, big sports motorbike wheel he took, which is little more broader. So that one, it can balance little more. Like with a single wheel also you can balance. The other thing required is you require some sensors which will maintain the flow of the wheel. Okay, it should not fall. It should maintain the balance. So for that, he used what is called the sensor. And after he used a sensor with some controllers. So sensor was a gyroscope. So this is the gyroscope. So after that, using the gyroscope and this controller, he made a prototype like this. Once a prototype started operating well, he implemented same in the original bike what he made. Okay, so this is how the whole system was made. So first, this is just a motivation for all the teachers there, that whenever we teach something to our students, try to make a prototype or make a hardware or make a model and show them, which will give a good idea for the students. Their students will be able to understand things clearly. So this is not only for electrical engineer, it may be from electronics, mechanical, not only engineers, even the other branches, those people in management or anything, whatever, whenever you do something, some prototyping or some model is very much important, which will some animations also you can make, which will be very useful. Okay, so this is a gyroscope, that is a sensor. Gyroscope is a device for measuring or maintaining the orientation based on the principle of angular momentum. Okay, so here you can see a gyroscope, and in this figure, when you see that here, the center one, this one rotates in the same direction, whatever may be the direction of the outer rims. See, outer rim is moving in any direction. Still, if you see, only the center one moves in the center. This rim always moves in a single direction. Okay, so that is what you can see in this. And a gyroscope in operation with freedom in all the three axes. The rotor will maintain its spin axis direction regardless of the orientation of the outer frame. Whatever may be the outer frame direction, the inner frame will always move in the same direction. So that's how the wheels of the motorcycle also will go in the same direction, whatever may be the outer rim, the outer structure direction. And this can be easily, this is a digital gyroscope that can be easily connected to a Arduino. So with this, when you put it into your hardware, automatically your system will operate. So this is a link where in YouTube you can just go and see this real time. The story which I told you is a real story. So this bike you can go and see in the YouTube, this link which is shown here. So now we'll go to the Arduino. So any controller, it is not that you have to go for Arduino, you can go for Raspberry Pi, Lego, or any controller. So you can see here you can see here the Arduino. So in this Arduino, these are the digital input output pins. Okay, you have 14 digital input output pins and you have PWM pins. The one sign, you can see a small white color line here. So these white color lines are nothing but the PWM generators. Digital PWMs can be generated from that. Similarly, you have analog. Say analog output inputs are there. There are 5 analog inputs you can give. So any types of input, like say the gyroscope which I showed you, or it may be a voltage sensor, current sensor, or any type stress sensor like vibration sensor, all those inputs can be given through these analog ports. Then you have 5 volts input, you can output, you can take it from here. If you want to take some outputs, you can take 5 volts, you want to take 3.3, all these things are available. And this is Atmega 328. So that's the microcontroller which is used here. Okay, so this is the USB port which you can connect it to your laptop, and this is the power supply. So next, this is Atmega 328, 5 volts supply is required for this board. 7 to 12 volts input. Say when you're acquiring some input from a vibration sensor or any sensor, 7 to 12 volts input can be given, is recommended, but it can go till 20, but it is recommended as 12. Up to 20, nothing will happen, but more than 20, it will get burned off. So that's why we give a limit of 12. Don't go beyond 12 in case some short circuit or something occurs. Till 20, it is not a problem. You have 14 digital input output pins and 6 PWM pins, which I showed you. Analog input pins are 6. Then the current, if you see, if you use 5 volts, it is 40 milliamps. And if you're using 3.3 volts input, that 50 milliamps you can get. Flash memory is 32 KB, is static RAM, and EEPROM is there, and clock speed is 16 megahertz. Okay, so here, just like C programming only, here also the programming is similar what you do in C, and other advantages, already the library has all the programs for connecting any keyboard or any Bluetooth device, or for connecting stepper motors or servo motors, and all these things you have already program written. So you need not write program, you have to just pick and drop those programs. So here you can see whenever you write the command, just like MATLAB only, but sorry, just like C programming. But here if you see pin mode, you want to define the pin mode. P is small, M is capital. Digital write, D is small, W is right, and there is no space. So this is how you define the function. Anyway, we will go into the library and this library of the software, and you can see this. So for MATLAB, when you want to have MATLAB supporting this Arduino, you require a support package that is available in MATLAB File Exchange. If you go to MATLAB File Exchange, in MATLAB File Exchange, MATLAB support package for Arduino is already available. From there, you can download it. So this here you can see the download option. Just click on it, you will get the download. So this Arduino PPT also I have already put in my slide share. I'll be showing my slide share link. From there you can go and get it. Okay, and these are different Arduinos. There are many types of Arduino. The Arduino which I am using is the basic model. Okay, Arduino Uno, Linode, Dio. You have both are a micro, Ethernet, robot for particular application, Mega, or you have Motor Shield for particular applications. You have for like image processing application, for audio processing, all these things. Many shields are already available. Lily pads are available for robotic applications. Also, you have number of things. So this is one of the small project, real-time hardware project which was done here. That was a inverter. So inverter converts AC to DC. So that was done here. You had a rectifier. This was the power circuit which operates at 230 volts, and this was a controller circuit which operates at lower voltage. Okay, here around 9 volts was the voltage at which this was operating. This is the microcontroller. It's generating. Microcontroller will just generate firing pulse for these thyristors to turn on. This circuit which I showed you, the same thing, hardware was also done. This was the complete setup which we did in the lab. This was the rectifier. This was the MOSFET bridge circuit. This was the overall Arduino circuit. So pulse, triggering pulses, this was generated in the CRO, and this was the output we got. So we gave DC input Okay, and the inverter, it converts DC to AC. So we got pulsating AC here. So AC supply, but it is not pure AC. It was a pulse, like stepped AC, you can say. You got stepped AC. So in our houses and all, you use inverter. So that there you have a battery. That battery is converted into AC. So this was the experiment we did in the lab. I'll be just doing the same thing in real Arduino and show you. Okay. Before that, you can just take my link here from where you can get the PPT. www.slideshare.net/ShimiRegi. SHIMIREJI. So if you go to this link, you will automatically get this PPT from where you can just see the content. Okay. So now let us go to Arduino and do the. So for Arduino, first of all, we have to open the Arduino software. Okay. First, I'll do the software, then we will go into the thing. So for software, so I've just downloaded the Arduino software. Let me see where it is. So here Arduino 1.06, I just downloaded from internet. You can go to the Arduino there according to your operating system, whether it is Windows, and according to the bits 32 or 64, you can just go and download it. So this Arduino is there. One second, actually I couldn't get this. Yeah, it's coming. So this is the Arduino icon. You can see here this blue color icon. Once you go to the website of Arduino and download this software, it's very simple. Go to Arduino. There, according to your operating system, it will give you a link. You have to just download that. Okay, and this window will come. These things are its supporting file. Now you just go and click on this Arduino. The Arduino window will open. And by the time it opens, what you have to do is you have to use the USB and the Arduino. Ma'am, just the gun. So you have the Arduino and this USB. You have to just plug into your system. Plug the USB into your system. Nothing else. You have to just plug in, and you can see the Arduino lights are glowing, in the sense it has turned on. Okay, you have just turned on. Now we have to just check whether this Arduino is connected in the software. Okay, but in the software you have to just check. So now let us go to the software window. So in there, my PPT. So now you can just go to the tools. Here there is an option, tools. Go to this tool. Go to boards. In that, you just see whether Arduino Uno is connected. Our model is Arduino Uno. So that should be connected. Okay. Sometimes if you are using some other model, that will be connected. Next, what you check is go to tools itself. Go to serial port and see to what COM port it is connected. It should be connected to some COM port. Here it is connected to COM port 3. If this USB is not plugged in properly, then the COM port will not be shown. So this is also very important. Two things which you check is, once you click on Arduino, you have to go to tools and check whether your board is connected and to which serial port or the COM port it is connected. Two things we have checked now. So now, as I already told you, you can just see the PPT. Go to files, examples. In that, all these programs are already written. Many basic programs are there. Analog, read serial, the bare minimum, blink, fade, digital programs are there for analog communication, sensors, display. All these programs are already existing. So what we will do, we will just open a very simple program of basics, blink program. So now the blink program is open. I can just show you the blink program. Okay, so this is for blinking an LED or just generating a firing pulse. So you can see the program here. Here it is void setup. So in MATLAB also, whenever you start a program, you write void. Whenever you don't want to send an argument, like when you don't want to output an argument, you write the command void. So same thing here also, you write void setup, and this is the function which will run only once. Okay, the first void setup will run only once. That is for initializing the pin. So pin mode, as I already told you, P should be small and capital M. 13 pin output. So I told in digital, in Arduino there are 14 pins, 0 to 13. In those pins are digital output input pins. You can define them as either output or input. So the 13th pin I am just keeping, let it be output pin. So pin mode 13 output. Next, again I have started one more loop, void loop. Again I'm starting digitally write the 13 pin as high. So I have to write the digitally write the 13 pin as high for 1 second. Delay for 1 second I gave. Again digitally write the 13 pin low. Again I'm giving a delay of 1000, like 1000 in the sense 1 second. Wait for a second. So this program we will just run it. Okay, it's a very simple program. What we have to run, we have to just upload it. So before this, there will be sometimes there is a problem. Okay, when you have connected the Arduino, you don't know this Arduino is connected or not. For checking that, what you can do, you can go to the device manager. So if you go to device manager, all those hardwares connected to your system, you can you can ensure that your Arduino is connected, because many of you, when you do it for the first time, sometimes your Arduino will not be connected. So in that case, you can go to your device manager and check whether your Arduino is connected or not. So here you can see the ports, COM ports. Go and click on this, say here Arduino Uno COM port 3 is connected. So this is just to recheck whether your Arduino is connected or not. So double click on this, a window will open. Here you can go and see the port setting also. So in this port setting, one thing you have to keep in mind is this bits per second, that is 9600. This is your screen resolution also you have set as 9600. In case your screen resolution setting and this setting is different, then there may be a problem. So you have to just check it whether it is 9600. Okay. So just click OK and just come, close it and come. So it is very simple in order to run this. Now we are not doing with MATLAB, we are just doing it with Arduino only. Just upload this program. You have to just click on this arrowhead. So the compiling of sketch will start. This window is said to be the sketch window. So this compiling the sketch will start and it will upload and the program will start running. So here I'm just connecting the LED, the ground to ground pin and 13 to the 13 pin. So it is uploading, so that's why it is blinking now. So now in the software, you can just go to the software 1 second. You can see done uploading is come. Software. So here you can see the option done uploading. So once it is done uploading, now you can come to the Arduino. So you can see there once it is uploaded, it is for 1 second, it is blinking 1 second off, 1 second on. Same thing, let me change, come to the PPT. So in this, let me change that, let it be off for a small, only like hundredths of a second. So in that case, I'm just uploading the program. So you can see, now it is the old program. Once it is like uploading, there will be a blink. So in the sense it is compiling sketch now. It is not uploaded till now. You can see a change because we have changed the program. And now it is uploading. So that's why it's blinking and done uploading. So now you can see it is off for a very small while. Only for a small while it is off and it is on for a larger while. 1 second it is on and for hundredths of a second it is off. Okay, so this is what we have done using MATLAB, with Arduino itself. Same thing, we are just going to do it with MATLAB. Okay, for MATLAB, what is required is there is a support package required. Okay, the support package in the library, let us go to the library, not in the library. I'm just going to my MATLAB file from where I showed you. For MATLAB support package, you have to take it from MathWorks. Okay, that is MATLAB file exchange. So there you can go to, see here, there is a PDF file. This is the file which I have opened from my MATLAB file exchange, PDE. Okay, in this PDE, if you double click, there is ADIO, analog digital input output, and again you have a file called adio.pde. So this is the file which is required, which you have to flash into this Arduino so that your Arduino can be interfaced with MATLAB. So this adio.pde file is very important file. So I'll just show you how to go into MATLAB and open this. Okay. So first go into MATLAB, and one thing you have to check is whether your Arduino is connected to COM port. Say serial port, it is connected. Now what we are doing, it will take only hardly 5 minutes. We will finish. I know all of you are very hungry. It is almost 1 o'clock. Only 5 minutes. It's very simple in MATLAB. I'll just show you. We are just going to create a graphical user interface. Till now I showed you the coding as well as simulating, but graphical user interface I didn't show because I just wanted to show it here. So for graphical user interface, you can just go to Home. In Home, New. Okay, in Home, New, if you go, you have graphical user interface. One option is here. Or you can just go and put guide in the command window. Guide, that is the command. So graphical user interface, I just clicked. My graphical user interface has opened. I am creating a blank GUI. So the blank GUI is open now. So now I have to put, I want 2 buttons, one to turn on my LED, one to turn off my LED. Okay, so I am just putting this push buttons, double click on the push button, change, I am just changing the color. Let me put a green color for this. Okay, and I can just push button name also, let me change it as on. Okay, similarly, push button 2 also I double clicked. I just put a red color for that push button 2, and I'm going a little fast, I know, because there is we are out of time. You can just go and watch this video later if you want to do it. So I just double clicked on these buttons, and I changed the color and the variable. Just double click, this window will open, and you will just go and change the color and this. Now in order to edit it, editor is available here. So this editor,
कुलदीप मैं क्लास में हूँ, आप आज आपको कूपन्स लेना है तो आ जाना यहाँ, मेरे पास है मोबाइल में। आईसीटी में नहीं पहुंचा है, मैं आ जाऊंगी 10 मिनट तक।
Okay, so here we have opened this editor. So once you open the editor, you can write the program, because we have put 2 push buttons. But once I push the first button, my LED should glow on, and when I put the next button, it should turn off. That should happen. So first of all, going into this, I forgot one thing. I have to burn this PDE program into my Arduino. Okay, so I am just my PPT. So first I will go my PPT. So here I will go into my Arduino, open my program, and in that my adio.pd, which one I said, that one I will click and I will open it in my window. So I've opened that, and now I will upload that program into my Arduino. So now this is a program which is already written for making it compatible with MATLAB. So we need not worry about it. That you have to just flash into this Arduino. So it is just getting flashed. So now it is uploaded. Okay, now it is uploaded. The program is uploaded. Now again what we do is, now we can just minimize this Arduino. Okay, now we can, anyway Arduino is ready to get compatible with this. Now we have to go to this editor. So when you go to the editor, it will ask, please save it. So now we have to save it. Let me save it in the location where my PD is there. That is again important, where I have my PD folder, that is which is compatible with MATLAB. See, this is the PD. So it should be near in that location. So I'll just name it as some test 1 2 3 4 or something. I'll keep it as test 1 2 3 4, and I'm just saving it. Okay, so this is the program. This is the program which has opened. That is a big program because I have created a GUI. Automatically back end, it will write a big program. There are 2 push buttons, and what I have put is come and Baki, the remaining program. So for this push buttons, I have to write the coding now. So I have already written the coding here. I'll just explain you the code also. So here, clear A. This is a small code. I'll just explain you this after pasting it there. Okay, this is clear A in the sense, once again, one more code is there. I'll just paste it. This is for turning on. You'll write digitally write high. So digitally high. As similarly, digital low. Digital low. Okay. So here you can see in this program, clear A, global A, in the sense MATLAB, if it has a variable A, that you have to clear it and you have to globally declare, because this variable is used in other function. A is equal to Arduino COM3. In COM3 port, we have our Arduino. I am putting it in a variable called A. Okay, so A is equal to Arduino COM3. Then A dot pin mode, 13 pin output. So actually, now this Arduino dot, the pin mode 13 pin, I am just keeping its output pin. Similarly, A dot digital write 13.1. So the 13th pin, I am keeping it as high, A dot digital write. Similarly, the 13 pin, I am writing it as low. When push button 2 is pressed, digital write 13 pin low. Okay, so this is the program which I have written. It's a simple thing. Other things are same. I have just defined the Arduino port and pin mode I have defined it. That's it. So now I'll go to the editor and just run this program. So I'm just running this program. So it is called this test 123 and it might be connecting it. Updating service code, is coming. Please wait. So once it is there, Arduino is connected, it will come. Then you can just operate on it. So it's very simple. You have to do step by step. That's it. It takes little time for updating. There is some problem. First, we have to keep a program in that location D where PD is there. So when you're doing the program, you have to be little careful. Okay, so first of all, it is in the PD now. Now I'll just call the test 1234. Let us once again check. Attempting to connect is coming. So we have to check everything. Arduino COM port 3, it is connected. Then we uploaded the program, that is also there. Some small error is coming. Now, anyone, if you have any doubts, because this is a procedure, there is some small error in connection or something. That's why it is happening. Otherwise, say it is now connected. Anyway, say Adreno, is successfully connected. And now I'm just clicking on on. You can see the here, like on my Adreno. Okay, so now let me click off. So it is off. Again on. Okay, so I'm leaving it. Now if I want to switch it now off, then let me again click on. So here you can just control by yourself. Okay, so this now with the buttons, I am just clicking it on and off and I am controlling it. Okay, so this is how you just control it. So it is very simple. Sometimes there may be some connection error, otherwise it is okay. So if you have any doubts, you can ask. I think it's lunch time. हाँ हेलो रुतला, मैं आ रही हूँ. हाँ मैं आ रही हूँ 5 मिनट तक, 5 मिनट मैं अभी क्लास खत्म हो गया. हाँ हाँ है आ रही हूँ. So if you have any doubts, you can ask. I was a little fast because I too didn't have time to complete it. But once you again go and see this video, you will understand it clearly. If you have any doubts, you can ask.
Any questions from any of the Nodal Center?
Yes, sir. Do you have any doubt? No doubts. Okay, so now we will break for lunch, and sharp at 2 o'clock, your next session will start. It is on what was it? Latex. Okay, so we have a research scholar who will be giving you an insight on latex and how to work on the software. So at sharp 2 o'clock, that session will start, and I request everyone to reassemble at sharp 2 o'clock. And if you have any doubts, you can call me, and my PPTs will be given to your ma'am. So she will be just like I'll be giving it to Bedi ma'am. So she will be sending it to you. Okay, thank you.
आ गया।
So very good afternoon, everybody at the various centers. So I welcome Dr. Rakesh Kumar from Computer Science Department of our institute. He has interacted with you on very first day on emerging areas of research in computer science. We have a little change in our schedule. Latex, which was to be discussed today, that is shifted to tomorrow afternoon session. And now Dr. Rakesh will interact with you on introduction to R. So as you know, R is a language and environment for statistical computing and graphics. It provides variety of statistical and graphical techniques. So we will first session we will just introduce with this R, and we will continue with this R on tomorrow also. The first session will be again on basic components of R, and that will be followed by graphical analysis. So I request Dr. Rakesh to interact with you on this software.
Good afternoon, participants present at NIRRR Chandigarh and at various remote centers. So initially we will discuss about the R programming, how R has been evolved, and what are the features that are available in this programming through which we can do our data analysis. This R programming is quite helpful nowadays as well as in the near future. We will discuss how R can be installed, what are the various features, what are the various functions and packages available in this. And later on at the end, we will discuss somewhat about the data mining, how data mining is done and why data mining is required and how it is done in R programming with the help of. And tomorrow we will discuss what are the various data structures and functions available in R that we can program here. So these are the contents that we are going to cover in this session. History of R, introduction to R programming, why it is required to learn the R programming. As we all know that we have lots of other languages like MATLAB is available with us. We have Python also nowadays people are working. SPSS is also, I think SPSS has also been covered in this STC. And there are some other tools also, those are available. So we will install the R, and then what is the integrated development environment for R programming. Some packages are also there. If I want to run some functions, then some packages needs to be installed in R programming. As we all know in C programming, suppose I want to use the printf function or scan function, so corresponding to that a header file should be included. So the task of header file is taken by the packages in R. So what R basically does and what are the things that cannot be done in R, then features and basic concepts of R, advantages and disadvantages in application, and what are the futures of R programming. This we will cover here. So this R basically evolved in 1970. At first time it was coined in Bell Labs, AT&T Bell Laboratories, and R basically evolved from the S language. Although R comes before the S in alphabetical order, but in practice this S language came before the R. In 1990s, R developed concurrently with the S, and in 1993 it was made public. But the stable version during this period, 1970s to 1993 and till 2005, 14 or you can say 15, no stable version was released by the proprietary these vendors. So stable version released on October 31st, 2004 by the R development core team under the GNU GPL license. The GNU, that is the GNU not for Unix, and GPL is the general public license. So R is a programming language and software environment for statistical analysis, graphics representation, and reporting. These are the things that we can do with the help of R programming. We can statistically analyze our data. We have the data sets at our hand. We can insert the data into this R programming environment, IDE environment. Then we can analyze it on different parameters. We can have the graphical representation in the form of either pie chart or some other forms of visual representation is also possible. We can also generate the reports. R was created by Ross and Roberts gentlemen at the University of Auckland, New Zealand. As I said, in 2014 it was the final version, that was stable version was released. R is a freely available under the GNU General Public License, and pre-compiled binary versions are provided for various operating systems like Unix, or nowadays we are all not using the Unix, rather we are using the Linux, Windows, and Mac. So 3 separate files are available for R. One is for Linux, Windows, and Mac. So we can just download this file and straight away install on our either Windows operating system or Linux or Mac operating system. R is basically a software distributed under the GNU style copyleft and an official part of the GNU project called the GNUs. So as this R is open source, so we can have the code of this R and we can do some changes in the code and write our own programs at the developer level also. The core of R is an interpreted computer language which allows branching and looping as well as modular programming using the functions. So here branch and loops control structures are also possible, and modular programming is also possible with the help of functions. R allows the integration with the procedures written in the C, C++, .NET, Python, or Fortran language for efficiency. So it means if we have some written procedures in the C or C++ or any other language, those mentioned here, we can straight away utilize those procedures and integrate them into the R. So that the knowledge that has already been put by some of the users, it can be further added on rather than doing the work from the scratch. So this slide shows why we should learn the R. As I mentioned earlier during this session, we have some other tools also like MATLAB, SPSS, and why should we go for R? Because first major reason is R is the open source language. If you go for MATLAB, we need the license for it, and in most of these places the license is not available, so we cannot do the research from our home, because most of us, those who are doing the research and using these tools for data analysis, sometimes we are at office or sometimes we are working at the home. So we need a common tool through which we can work. So cross-platform compatibility is also supported here in R. As I said, if we have the procedures written in C, C++, Python, .NET, so those procedures can be integrated into the R. So cross-platform compatibility is there. Advanced statistical language, a lot of functions, those are integrated into the R programming here. So we can straight away use these functions and generate the results. We are not required to write the complete functions for some task. Like suppose if I want to calculate the addition of two numbers, so the operator addition has already been programmed into the background of R, so we can generate the results. This is the simplest one, that addition, but there are some other tools, or like we can compute the length of a vector. So for that we have some inbuilt functions, those are written here. So graphs generated or reports generated by this R is very, very good and user friendly. Users are able to understand it very easily. So nowadays most of the researchers or the technical people, those are working in the industry, they are using this tool, and the graphs generated through this are very, very good, and they can straight away demonstrate these graphs to their higher authority or their managerial team. And this R also relates to the other programming languages, as I said. So this is also good, or it is the one advantages of R. Vast community is using this R, so a lot of blogs and supports are available on the internet. So if I want to do something, we can just take the help from these community. And supports the extension also, extremely comprehensive. A lot of functions are integrated in this R, and a major advantage of R is that as soon as I install this R, the minimum required functions are automatically installed, and after that, whichever function I want to install, I need to install it explicitly. So it will take very less space on the hard disk, although there are a lot of functions available in the R that we can use it. But automatically it will install the minimum one. So this slide shows the comparison of R with some of the key competitors like Python and Java. So R was stably released in 2014, and as mentioned here, and Python and Java are comparatively the older one. So Python was released in 1996 and Java was in 1995. So as soon as the languages, the new language is evolved, or it is just the extended version of the previous one, more and more functions are integrated into the programming environment. So some of the functions, those are not directly available in the Python or Java, they can straight away available in R programming here. So it has more functions and packages, as I said, as compared to the Python and Java. It is an interpreter-based language. Python is also an interpreter-based language, but Java is interpreter and compiler-based language. We need the compiler here. So it is statistical design and graphic programming language. Here we can generate the graphs and we can generate the reports for this. It is a general purpose language. Python is general purpose language. Here reporting or graphical features are not dedicatedly available. You can write our code to generate the graph, but no straight away tool is available there. Likewise, it is difficult to learn and understand. It is slightly difficult, not somewhat difficult. It is difficult to learn the R programming, but as it is a new one, so we need to put some effort to learn this programming language compared to the Python and Java, because we are using this Java and Python for the last more than 20 years. So it is comparatively difficult. R is mostly used for data analysis, whereas Python and Java are multi-purpose language or general purpose languages. They are used for some other purpose also. Even some tools or softwares are written in Java, whereas R is dedicatedly used for the data analysis. This Kaggle is one of the community that is widely using this R, and it has most of the participants here. You can see here we go for big data to big data analytics using this R. So people are using nowadays. You can see in this slide the blue portion shows the people who are using the R tool as compared to the other one. Like we can see here, MATLAB, very few people are using. In SAS, Weka, SPSS, Python, Excel, Mathematica, Stata, and some other tools are also available. Those are being used by the people for this data analysis. These are the data scientists. For these companies, they use this, and because we have mentioned a lot of advantages are there for using the R, as it is mentioned here, Google people, they say, what is your programming language of choice, R, Python, or something else? This is the feedback from these Apple and Google. You can see here, I use R and occasionally MATLAB for data analysis. There is a large, active, and extremely knowledgeable R community at Google. And with respect to Apple, we can say expert knowledge of SAS with enterprise guide minor required, and candidates with strong knowledge of R will be preferred in Apple. So this shows that this R is quite popular nowadays, and people have started using it. Commercial support for R is also available. We have a Revolution Analytics provider commercial support for the Revolution of R. This is a link that is given here. And Big Data Appliance, which integrates R, Apache Hadoop, Oracle Enterprise, Linux, and a NoSQL database with the Exadata hardware. So this integration is also possible of R with this Apache Hadoop Oracle Enterprise, and the link shows this slide shows the revolution for R. And we can see here the base version, that is R 2.14.264, and Revolution R 1 crore and Revolution R 4 crore. We can see the speed up. So 7-point metrics calculation, it is very fast. It is 7.9 times faster here. Metrics functions, we have 7.8 times faster speed up there. Program control is also very good in this, and moreover it is free also. So now moving on to the installation of R, how we can install it. We just first see the steps of installation, then we will install it on this machine, and you can also see it. So you can directly install the R using the www.rproject.org. And if you want to install the RStudio, that is just a third-party software that provides a graphical user interface for this, that is the RStudio. But you will see now the R only, R tool, that comes under the CRAN project, CRAN project. So when you start downloading this, it will show you the multiple servers through which you can download. So the server which is most nearer to you, it is recommended to download from there. You can download it. Then, as I mentioned in the start, we have 3 different binary files for Linux, Mac, and Windows. You can download the appropriate one, and then you can run the setup function. It will show you the GNU General Public License, as I mentioned. You can press the next. Then you can mention the place where you want to install this. The setup will install the R for Windows in the appropriate folder, which you will mention here. Then it will ask for to startup option. So you can choose the default one. Then it will show you for the menu folder. You can choose the default one. Here also you can choose the default one key if you want to create the desktop icon and associated files. So it will then install the R on your machine. So we will try to install this R. So we can download it from here. Download the R. I think this particular link is down at this moment. So we'll try to install it later. There is some problem with this link at this moment. Our project में चल रहा है? Is it working?
इससे तो नहीं हो रहा.
So we are trying to install it. It's taking some time. How that is our studio actually. I want to install it from here. This is the exact link through which it is to be installed official source. But anyhow, so we can choose the language. This is a complete R for Windows setup wizard. And press here. It is showing you the general public license issued 1991. And press next. You can choose the appropriate location where we want to install. You can choose the by default one also, or we can change it here. Suppose I want to install it onto the some other location. Or let it be there only. So this is 32-bit machine, man. This is 32-bit machine or 64-bit? Set the default R. So it will install it. नहीं हुआ?
वाला डिस्कनेक्ट हुआ. दो सेम प्रॉब्लम.
So it's saying that the installation is complete. You can press the finish. You can check whether it is properly installed or not. This icon will come on your screen. You will double click it, then this R environment will be opened. So we can do our work here. This is basically the console one. If we install the R Studio, then it will show you the graphical version. So in this, if I want to install any of the package or function, I need to dedicatedly type here. But in RStudio, we have the whole graphical user interface, and we can install the thing through the mouse click only. So we will also try to install the RStudio, then we will move further. This the default of this default version of R is basically the console is in the console mode only. But if I install the RStudio, so we can download the free version of RStudio. It is asking for which platform, for which platform you want this. So if I want basically RStudio for Windows, so I will click here. Through this link, you can download it for the Windows. For Linux, you can click these two links. And for Fedora, you can download it from here. So as RStudio supports the graphical version, it is somewhat larger as compared to the normal R programming IDE environment. So when you download it, this will be approximately 118 MB, and the normal R it is around 30 to 40 MB file. We'll download it there. Unzip it here. It will take some time, and after that this will be installed. So working on RStudio is comparatively easier as compared to the R, because there we need to write all the commands on the console, but in RStudio we can do it through graphically. So it will take another 1 or 2 minutes. Huh.
Parameters of feature variables that actually important
Yeah, there is a query from the participant from NITTTR. He's asking that if there are 2-3 variables, then can we analyze the data easily in R? So the answer is yeah, this R is very user friendly and we can easily do this. As this machine is basically connected to this servers and connected to very remote center, that is why it has become very slow. Otherwise, if I am working on a dedicated machine and I am doing the R programming, this is very fast. We can write the program for it and we can do it very efficiently. Yeah, as I said earlier, this R and there is some problem with this, but you can do it on your machine. Just these are simple steps you can follow. As I said earlier, this R and SPSS are the latest tools. Those are launched, I think, in the last couple of years. The other tools like Java and Python, these are quite old tools available with us. But SPSS and MATLAB, these are the proprietary source item source, and we need the license for it. Yeah, but for R there is no license required, and it is also very efficient if I compare it with the MATLAB and SPSS. So we'll move to the PPT where we will see that. So we have seen that we can install the R through this way. We can also install the R Studio. There was some error in the end here, but we can install it like this only. There are two integrated development environments for R programming: RGUI, Graphical User Interface, and R Studio, as I said. R Studio, as I said, it is somewhat larger as compared to the R because it supports the graphical user interface. This is the R console version. So when your R is properly installed, this screen you will get, and you can write your program or equation, whatever you want to analyze the data, you can write here. So when you are working with the R, so as I mentioned at the beginning, all the packages or functions are not installed by default. Rather, the minimum number of functions are installed by default. So whenever suppose I am working on it, the continuous internet connection is required, because suppose I want to perform some task and that particular task has already been integrated in some particular function and that is in the particular package. So I want to install the particular package at particular moment, then I need the internet connection. So it is always advisable to have the continuous internet connection whenever you are working with the R programming. In R Studio, in R, you will get only the one console window, as you can see here, but in R Studio you will get the 4. Here you can write the code in R Studio. You can write the code here, and this is the R console. This is the workspace and history. Here you will find the, suppose, very temporary variables, what values are assigned to these variables, that will be shown here. And in this you will find the graphs if you have any graph in your file. You can also install the packages. As I mentioned, here there is a button for the packages. Just enable this tab and write the package name and just click it and it will automatically install. But in R console you need to write the complete package name, and there should be no error in the syntax error in your package name. So a package is basically a collection of functions with comprehensive documents. Package includes R functions, data example, help files, namespace, and description. All these things are described in these functions. Default installation is kept as minimum, as I said. So not all the functions or packages are installed by default. So the function of R could be extended by loading the R package. So we can extend the functionality of the R with the help of these packages. So as you can see here, if you want to install any package, you can just write the package name and again choose the appropriate server. As mentioned here, ki HTTPS CRAN mirror. So you can choose the server which is nearest to you. That will enhance your downloading speed here. Then these are the packages, like you can see here, A3, ABBYYR, ABC. These are number of packages are available. You can install which package you want. So to load a package, you need to write the library and in braces the package name. And for contents of package, just type the library help is equal to package name. It will show you the appropriate package for you, which will be the most suitable for you. And for additional documentation, you can go to the cran.r-project.org. This is basically the project through which this R programming has been evolved. And there is a reference manual also available there. And we can see here that some packages may override the contents or functions in another package. So when this happens, it will be indicated in the log. There are some packages, those are not, you can say, they exactly compatible to each other. If you use one, it may also overwrite some of the data in the other functions. So always install only those functions or packages that you really want. So to analyze it, whether it has really overlapped some of the variables or not, you need to go to the log and there you can find it. And this is the some advanced loading packages. You can, through this you can load the packages. To find out what packages are already installed on a computer, you can use the command installed.packages and braces. No need to write anything on the braces. It will show you the packages those are already installed on your R. And to check if a given package is installed or not, you can also write is.installed, then this arrow mark, less than symbol, then hyphen, then function my package. Or you can also write is.element my package install.packages and braces. Through this you can find whether a particular package is installed or not. And with the first command install.packages, you will get all the packages those are installed on your machine. Because as I said, some packages may interfere with each other and may result in overwriting of data. So to check appropriately, you can check the log files and accordingly you can take action here. To install a package without clicking through Windows, you can write install.package and package name. So these last two commands are particularly helpful when writing functions for other users. We may also need to read the data from the files. For that, we can use the read.table function. Suppose some of the data are there in some other files, and we need to import that file into our R environment. So for that, we can use this. So to read an entire data frame directly, the external file will normally have a special form. It will not read all just raw data. There should be some format. Your data should be in some format through which it can directly retrieve the data from that particular file. The first line of the file should have a name for each variable in the data frame. As we can see here, the first line is having price, floor, area, rooms, age, and send.heat. And each additional line of a file has its first item a row label. As mentioned here, we have a data in a tabular format where we have 7 columns here and we have 6 rows here. Out of this, the first one is the header, which shows this entire data in the form of the name, like this here we have price, floor, as mentioned earlier. And the first column, it is mentioned here, the first column, it should show the row label. So here we use the row label as 1, 2, 3, 4, 5. So numeric variables and non-numeric variables are also possible here. Yeah, you can You can retrieve the data from the Excel file to the R programming directly. So reading data files, you can also write like house price, then read.table, then house.data, header is equal to true. So it will read the data from these particular files. Those are in a tabular format. Data file is named here input.dat. Suppose the data vectors are of equal length and are to be in parallel. Suppose that there are 3 vectors, the first of mode character and the remaining 2 of mode numeric. So we can choose different mode for the vectors that we will see in the next class tomorrow. So the scan function can also be used for scanning these functions like inp scan input.data list. I can mention the blank and then 00. So through this it can scan these data from the files. We can also store, every R object can be stored into and restored from a file with the command save and load. We can save the whole project with the help of save command, and when we want to again work on the same file, we can load it from the hard disk. So this uses the XDR, that is the external data representation standard of Sun Microsystem and others, and is portable between the MS Windows, Unix and Mac operating system. So we can just write the save x file is equal to x.r data and load. Will be the loading the x.r data from the hard disk that is saved earlier. And this is about the importing and exporting the data. As you mentioned here, can we import the data directly from the Excel? So this is also possible. And you can see here there are many ways to get data into R and out of R. Most programs like Excel, as well as humans, know how to deal with rectangular tables in the form of tab delimited text files. So X is equal to read.delim filename.txt. So it will read the data from these Excel files. We can choose the different delimiter also for retrieving the data. So what we can do in the R, these are the possibilities that we can do here. We can do the data handling and storage, numeric as well as the textual. So we can create the vectors or arrays or variables with the help of providing the appropriate names, and we can have numeric as well as the textual data. Here in this R, it is not required to provide the data type to each and every variable. It will automatically take the appropriate data type for the variable. Just to write the variable name and assign the value, it will automatically take the appropriate data type for it. Like in C, we need to declare, suppose, one variable. We will write int a. It means variable a is of integer type. Here it is not required to initialize the variable with the data type. You just straight away write a is equal to 7. So it will automatically initialize a as an integer type variable. So matrix algebra is also possible. Hash tables are also possible to implement in this R environment. High-level data analytics and statistical functions are possible. We can have the classes, object-oriented classes here. Graphics representation, as I mentioned earlier, we can form the graphs, pie charts, and visual representations through other ways. We can also support loops, branching, and subroutines in the R programming. So if statement, if else, that is also possible for while. These are also possible in R. But what it does not support, it is not a database. R is not a database or database management system. R has no graphical user interface, but it can connect to Java. Although we have RStudio in which this graphical interface is provided, but the basic R environment, that is the console mode, that does not support this. So it is a language interpreter, can be very slow, but allows to call own C or C++ code. As I mentioned initially, this also supports the integration of the code from the C, C++, .NET, Java, but it will somewhat slow down this R environment. So no spreadsheet view of data is possible, but we need to connect to the Excel. If we want to just visualize the data in a form of spreadsheet, we need to go to the Excel. And no professional or commercial support is available. Although a lot of blogs are available, but those are no guaranteed one. Sometimes we get very good information from the blogs and free of cost, but that information is not guaranteed one. If you are doing some research and doing the study purpose, then we can rely upon these sources like blogs on some unofficial source of help. But suppose if you are doing the data analysis for some large or a big company where the data is very, very crucial, we cannot rely upon these sources. We need the official help from the appropriate agencies. That is not available in R. So these are some of the features of R programming. It is a well-developed, simple and effective programming language. It has an effective data handling and storage facility. R also provides a suite of operators for calculations on arrays list, vectors, and matrices. These are possible here. R provides a large, coherent, and integrated collection of tools for data analysis. A lot of functions and packages are there in R. Through that, we can do the data analysis. R provides the graphical facilities for data analysis and display either directly at the computer or printing at the papers. We can do the report, we can generate the reports in R also. These are the statistics which shows the usage of R to the last couple of years. You can see the 76% of analytic professionals report using the R, and 36% select R as their primary tool out of this. The people, those who are working on the data analysis. These are the advantages of R. R is the free and open source software. No license restriction. We can write our own code. We can go up to the developers level. But for that, we need a good programming capability to do the changes in the code. R has over 4,800 packages available from multiple repositories specializing in topics like econometrics, data mining, spatial analysis, and bioinformatics. So if we install all of these packages, because these packages are from the multiple repositories, that is why they sometimes interfere with each other. So it is always advisable to learn the help file for each package before installing it. R also support the cross-platform. R plays well with many other tools, importing data from like CSV files, SAS files, Excel files. It can also produce the graphical output in PDF, JPEG, PNG, SVG formats. These are some disadvantages of R. Average memory performance, poor management of large data set. When the data set increases, there are some problems with this, but this also happens with others also. Like if we go to MATLAB and SPSS, there also if the data set increases, the performance or the computation efficiency of a machine also decreases. So complicated structure of packages in R, average computing performance, no default parallel execution. Default parallel execution is not provided in R. We need to do some extended programming here. After that, it will be enabled. Difficult data visualization and management, difficult to inspect the data sets, and relatively difficult to learn very complex data structures. Those are available in this. And in this slide, we can see here R programming has turned into the most prevalent language for data science. During the past few years, we have seen 76% of the users have suggested that we are using the R programming. And it is a fundamental tool for finance as well as the analytic driven organization. Like we can see here, Google, Facebook, LinkedIn, all these are using this. So R is the open source data analytics. Object oriented features are also supported here. High-end graphics are also supported. Integrated language, advanced analytics, and large communities also there who are using this. This is somewhat the future of R programming. It is a good and a powerful because R is one of the most demanded scripting language developed by and for statisticians. There's unparalleled advantages. We predict the present and future of business analytics with the R only. So now we will do some of the basic exercises in R so that we can learn how we can do the programming in R. We have already installed the R. So those of you who have not yet installed the R on your machine, you can take 5 minutes and install the R on your machine so that we can do some basic programming on R. Have you installed, sir? You can just try, sir. We can have 5 minutes, and after that we will start doing some exercises on R.
ये तो प्रैक्टिकली नहीं तो होगा तो मजा नहीं है।
Sir, there is some technical problem with our college, so we are not able to download this R.
Okay.
That is not the cards we need.
Now we are going to share this file. Now we are going to share this file.
This is very good.
Then just write the download R. Just go to this link and just download it from here. It may be possible that in 1 or 2 remote center it may not be downloaded, but in rest of the centers it should be downloaded, I think. Just take 2-3 minutes so that we can install in the meanwhile, and then we will start. So I hope the participants have installed the R on their machine. So have you installed, sir? In this R, we can do the basic programming, like we can create, suppose I want to create the variable in this. So in C programming, suppose I want to create a variable A. So first I will write the int A, then I will assign the value A is equal to 5. Here no such thing is required. We can straight away assign the value to any of the variable. I've written A as the 5. So the value of A is assigned here as the 5. You can see the value here. Now I have assigned the value of b, I suppose 6. So you can see here the value of b is assigned 6 here. So I have mentioned here two ways of assigning the values to a variable. A is equal to 5 will assign the value 5 to a, and with this arrow operator also it is possible to assign the value to the variable. I have written b and then arrow operator then 6, it assigns the value 6 to the b. Now suppose if I add a plus b, then you can see the answer here has the 11. I think it is not possible to further increase this size. So you can also assign this addition of two variable to the third variable. So I've assigned c is equals to a plus b. So it will assign 11 to the c. C arrow operator a plus b. So it was assigned a plus b to the c. C is equals to a plus b. Both the methods are correct. Either you can write c is equal to a plus b, or you can write c arrow operator a plus b. These both are basically the assignment operators in this R programming. We can use any of it. So when we do this data analysis, the first thing is in data analysis basically the data, that is basically your useful information, and from where you are going to collect this. If the data is your primary data, then it means your data is directly collected from the users, and this is the most appropriate or the actual data on which we should do the analysis. But this is a very tedious task, collecting the data from different people who are actually concerned with this. And the second way is the data that is retrieved from the internet, that is known as the secondary data. And in this case, we have a lot of repositories available on the internet. Data sets are available. We can download it and straight away start using it. Your data may be descriptive or inferential, and we can perform the quantitative as well as the qualitative analysis. I also mentioned the way of doing the research on my lecture on the very first day. I mentioned about the qualitative and quantitative kind of research, but in which in the way we are going to perform our research and going to propose the solution in the way of like this solution is 70% time better as compared to the previous one. It is somewhat quantitative type of research here. So in R, we have different data structures available. Like we can create the vectors here, we can create the matrix here, we can have the arrays, vectors, list, and all these things are possible to create in R. Right now we have seen only the simple way of assigning the value to the variable and just simple operation. We can also do this like we can have d is equal to a plus b plus c minus d. So here it is showing the error as d is not found, because at this moment we have not yet declared the variable d. We have not assigned the value to the d. That is why there is some error. So we can also create the vectors here. Like in the previous case, we have just created the variables. Now we are going to create the vectors. Vectors are basically your one-dimensional array. You can say one-dimensional array. So I have written x equals to c. Suppose I assign the value 5, 25, 30, 25, 26. This vector x has been created. C is basically the keyword here that is used for the creation of vector x. You can see the value of this vector x as 5, 25, 30, 25, and 26 that we have assigned here to the vectors. If I want to specifically see the item number third in this vector is basically an array, one-dimensional array here. So if I want to specifically see the item at number 3, so I will type x location number 3. It will give the element number 3 to me. It will display the element number 3. So in this case, it is 30 here. Likewise, we can straight away go to any of the element. Right, 26. So in C programming, generally this counter starts from the 0, but here the counter starts from the 1. The base value is here 1. There is another way of assigning this values to the variables for your vector. So this is another way of creating the vector. First, I have used the arrow operator. Now I have used the assign function here through which we can create the vector. So here I have created the vector y with the different values in it. We can also create a new vector from the existing one. As I mentioned in the variables also, we can use the either equal to operator or the arrow operator. Both are same. Here also we can use the both of this. Here I have created a vector z. I have used the keyword C for creation. Elements, here I have taken 2 elements, and the first element is the second element of vector x that has already been created, and the second element is the fourth element of vector y. So in this way it will take or retrieve the values from vector x and vector y. Through this we can create it. You can also try this, creating the vectors from the existing one. Have you executed, sir? You can try. So this is the first way of creating the vectors. In this, we have assigned the values explicitly here. But when suppose the number of values are very, very large in any vector, then this method is not appropriate. Suppose your vector is having suppose 50 values or 100 values, then this method is not appropriate. We need to specify all the values dedicatedly here. So another way of creating the vector is you can do it with the help of repeat command. Like suppose I have created a vector a here. A is equals to repeat. But in this case, there should be a proper sequencing in the element. Here I have written a is equals to repeat braces 1 colon 15 comma times is equals to 2 and braces close. So it will create the elements 1 to 15 and repeat it for the 2 times. So a total of 30 elements are assigned to a vector A here. Equal to 2. 2. Number of times you want to repeat it. Okay. We can also assign the non-numeric values to these vectors using the comma, inverted commas. Whether you can apply the single inverted comma or use the double inverted comma, both will work. You can assign the value to your textual vector in this. Whatever value you can assign, just non-numeric value. Whenever you are going to assign the non-numeric value, it should be in the quotes. If you are going to assign the numeric value, then you can assign it directly. Like you can see here, suppose I have given f is equal to 8. Then I have written g is equal to f. If I print g here, then it will be having a value 8. I have written here f is equal to 8, g is equal to f, and now I have printed g. It is showing the result as 8. This is basically a numeric vector. Numeric value is assigned to f, and then that particular value is passed on to the g. This is a variable here. Okay. So we have learned two methods of creating the vector. First one is by explicitly providing the various elements of the vector, but in this way we cannot provide the large number of elements to the vector. Second method we have learned, that is the repetition. Suppose the same particular sequence is repeated number of times, that we can do it with the help of repeat keyword. And there is another method of creating a vector with the help of sequence. Then we can see here I've written b is equal to sequence from 1 to 20 by is equal to 2. So this is third way of creating the vector. That is with the help of sequence. It is somewhat equivalent to the for loop. For I is equal to 1 to 10 and the increment you are specifying here. Same is the case here. So B is equal to sequence from 1 to 20 by 2. There will be an increment of 2 here. Suppose if I create a vector, see here, sequence suppose 1 to 50, and I have given an increment of 3. And see the value 1, 4, 7, 10, 13, 16 up to 49. So you can note the few questions or few exercises that you can do with this, the way of creating the vectors. First is the create a numerical vector x. Create a numerical vector x. Question number 1 is create a numerical vector x with elements with elements and is the create a numerical vector y with elements 2, 6, 11, 12, 15, 18 using the assign function. Create a vector z from with elements from 5 to 20 and repeated for 3 times. You need to do these 5 questions. These are the examples through which I have created the vector. I have shown you the 3 methods through which we can create the vectors, and in which situation which one will be the better way of creating the vector. On the basis of these, I have given you some problems to do. I request all the participants at the remote centers to please install this R on their laptop or the machine that they are having or using, and try to solve these problems. So these are the solutions through which you can create the vectors for these appropriate situations. Now moving further, after creating this vector, we have some inbuilt functions available in the R that we can straight away use to calculate, like the length of a vector, mode of a vector, sort, minimum to find the minimum or a maximum. We can see one by one. So now we have a lot of vectors created here. We can see vector here as A, B, C, we have B. These are the vectors that we have already created, and these are the values in this. So suppose I want to first calculate the length of a vector. I want to calculate the suppose length of vector E. It shows that the length of vector is 50. We just straight away write the length in braces में name of the vector. Yeah, it will give you the length of the vector. You can also add length and name of vector. Here I have created many of the vectors. I have chosen the E here. You can write anyone. You can also see the type vector. I have written mode E. It says that the type or the mode of vector E is numeric. If you see the same for A, it will show you the character, because the vector A is initialized as a character vector, whereas the vector E is initialized as a numeric vector. So with the help of mode, we can check the type of a vector, mode and the vector name. We can also sort the vector, like sort name of the vector. I'm taking X, then it has sorted the vector in the ascending order. Earlier, the elements in X were 5, 25, 30, 25, and 26. Now it has sorted it. But actually, the elements remain same. You can see here I have displayed the elements of vector X as 5, 25, 30, 25, and 26. So when you sort the vector, it will just show you the values onto the screen only. If you want to save these values, you can pass these values onto some other vectors or on the X itself. I have sorted the vector X and stored the values into itself. So now if I display the value of X, we will find the sorted values. Sorted values are displayed here. Okay. If I want to sort the vector in decreasing order, that is also possible. We write here decreasing is equal to true. It will show the value of X as 30, 26, 25, 25, and 5. The vector is sorted in decreasing order. All these functions are case sensitive, so which I have written in capital letter, it should be in capital only. Is equals to true. I want to sort it in the decreasing order. So I've written vector sort the vector name and decrease equals to true. Suppose I want to find the lowest amongst all the values of a vector. So I have written min or vector name. Give you the 5. 5 is the lowest element in this vector.
The repetition of the vector, for example, 1, 1, 2, 2, 3, 3, and up to 1 up to 20, right? And, maximum number of repetition. I want to some all repetition to
All repetition should be? No, we have only limited functions. For that, you can write your own, create your own function, and put it onto the repository so that other can also download it. Or you can check it with the repositories those we are having, whether this type of function has been created or not till date, because people are working day by day on this and they are creating their own functions and packages and they are putting it onto the repositories. As far as my knowledge, it is not available till date. Maybe some people has added, then you can check it through the help of repository. So likewise, we can compute the maximum. Max will give you the maximum value. Here I have chosen the vector y, so it will showing you the value for vector y. Suppose I want to add all the elements of a vector. For that, we just write sum of x. It will give you the sum of all the elements of x. Suppose I want to add a particular value to all the elements of a particular vector, then that is also possible. Like here I have 5 elements in x. Suppose I want to add 10 to each element. So I will write x plus 10. 10 is added to each of the element of x
x
plus 10. Just like we add the variable like a plus 10, it will add 10 to a. So here the variable is a vector, that is why it has added 10 to each element of the vector. You can also do the addition of two vectors. I have added the vector x and vector. If I add x plus y, we get this result. Addition of two vectors is possible. Likewise, the subtraction of vector is also possible. You can do the x minus y also. You can also do the multiplication of vector. You can also do the division. We can also compute a particular equation also. Yeah, in the form of vector. Like suppose if I have written here, h is equals to computed the some equation with the help of a vector also. This is also possible.
A square plus B square.
Yeah, all mathematical question. So like you compute a multiplied by a, then this is also possible.
A square plus B square कर दिया.
Yeah. Square is also possible. Suppose if you want to compute x raised to the power, this is also possible, raised to the power. Okay. We can also create the column vectors here. Like, suppose I'm going to create colors. Or you can say the character vector. Basically, this is not a column exactly. Character vector is the appropriate name. So we can have the character vectors also. If I want to check the mode, we can have the mode and then the vector name. Shows the character vector. We can also check it with the help of other way, as I mentioned in the slide, is dot character, then the vector name. It is saying that it is true. Is dot character, then the vector name, that is the colors. I want to check whether colors is a character vector or not. It is showing it as a true. If I write is a dot numeric, that is showing as the false. If I execute the same statement for vector x, then it will give you the reverse result as with respect to the vector colors, because x is a numeric vector. So for is dot numeric, it is giving us the true, and for is dot character, it is giving us the false result. And for the reverse case, it is for the colors. For character, it is giving the true, and for numeric, it is giving the false. We can also create the logical vectors. Suppose I have created c is equal to 2, 2, not applicable, suppose false, comma,
The color is red star, red star. Red is star red for the colors.
colors, then c is for creation.
Which calculate is only continuously.
Here colors is equal to c, then braces, then quotes, then you can provide the element name. Suppose there are some elements in the vector x like 12, 9, -2, 4 and 10. I want to check how many of them are less than 0. So 12 is greater than 0, that is why it is giving the result as false. Then again for 9, same case, -2 is less than 0, that is why it is giving the result as true, then false and false. So we can check logically whether the values are greater than or less than equals to the different one. Through this way, you can create the different types of vectors and check their mood. So in the tomorrow class, we will learn about the matrices and the further about the other functions and keys through which we can perform various operations in R programming. In the meanwhile, if there is any query from the remote center, then we can have now.
And question for any through the center. Gandhi Engineering College, sir, do you have any question? Gandhi Engineering College.
सर देखो प्लीज कॉल के पास हो मेरे फोन ये कैसे बोल प्लेट है हाँ
So I think there is no query from the various participants present at remote center. So today we have learned about the basic programming of R, how it is useful as compared to the other programming tool like MATLAB, Python and Java. We have learned how to install the R and the basic creation of variables and performing some fundamental operations on these variables and the vectors. So thank you for your patience hearing. In tomorrow class, we will be learning the other functions. Those are possible in the R programming. So thank you. If you have any query, you can also post your query to the email ID available on our institute website.